All right, I'm back. Link up stuff other than clips where I'm embarrassed to watch. Nope, it's just links of that. Okay, all right. Okay. All right.
Discovery, go and throttle up.
Creeper, I got your 3. Arsenal, what is? Oh, that's the moon. Okay. Hey, Buffalo, 12-month resub. Thank you. Thank you for the year, buddy. I appreciate it. Very much appreciated. All right. What do you guys want to talk about? Relativity with a test stand, from what I can tell. Stranus is doing some stuff. Okay, there's the FAA stuff with Starship. Ajox, what are you linking? Ooh, a video from Rocket Lab about LC2. All right. For a whole second, I paused it. And from Administrator Senator Bill Nelson. Okay. All right. Not gonna be an incredibly long space news today, I don't think, unless you guys want to talk about stuff. Unless you do. Yeah. Just looking around here real quick. Don't forget this. Is that... Oh, Bandit, we talked about that for Space News yesterday. Yeah, already been covered. Thank you. Wasn't here. All good. All good, man.
Discovery, go and throttle up.
Let's see. Okay. Hey, Tessa, Tier 395. I want to talk about Windows 95. It's the next big thing. I have the FAA one already. Yes. Not Tessa Creeper. Thank you. Tessa Creeper? Creeper Tessa? All right, so here. Let's start with the Starlink mission that ended up going last night. Let's melt into this. We can watch a replay real quick. Hyped about the Fallout TV show. Looks good, man. We'll see. We'll see. Oh, yeah. Didn't that come out today or something? It was the best 95 reference I could come up with, but not a 95 reference? All right. So this was the Starlink 618 mission, I think, last night. Or 648, excuse me, 648. I misspoke. This was out of pad 40. This was very, very late last night. Like, very late. This thing went at about 1 in the morning. Here, let's get to the good stuff.
-10.
This was a relatively new booster.
7,
1082. This was only its second
5,
flight, so it was
4,
like... Okay.
3, 2, 1. Engines full power and liftoff. Go Falcon, go Starlink.
Everything looks good there.
Vehicles pitching downrange.
Down what do you team pressures? Power until.
All right, let's get to the good stuff. Different camera up there. That's looking up the second
Pico.
stage here.
Stage separation confirmed. And back ignition.
1083.2. Is that the newest one? Hold on. Should be coming up on fairing step here. Separation confirmed.
Fairing separation confirmed.
This booster previously supported Crew 8. That's okay. What's that, Bandit? Interesting. Interesting, Bandit. Yeah, we'll talk about that, sure. All right, let's get to the good part.
FTS is saved.
So this was a
Stage one,
replay from last
start
night.
up.
There's your supersonic retro propulsion. He said it. He said it. You heard it here first. That's a long burn.
Stage 1 entry burn shutdown.
Oh, dude, look at
Stage 2 FTS is safe.
Dude. Dude. That's sweet. Wow. Super uninterrupted footage. Look at all the plasma accumulation on the grid fins. That's awesome.
Stage 1 transonic.
There we go.
Stage 1 landing burn.
Here's your landing burn. All right, T-Man, let's see.
Stage 2 is in terminal guidance.
Let's see what's up. Okay, a little bit of
Nice
chop on the
deployed.
water last night.
Stage 1 landing confirmed.
It's fine. That was fine. That's just residual. Yeah, it's hard to see without that, but yeah, it looks like so we're seeing fire right here during a landing, and it's clearly up above the engine nozzles. Usually fire that's above your engine nozzles is probably not what you want. Just putting it out there. It looks like some of the dump from the E9 engine, the gas generator dump, caught on fire a little bit.
Stage 1 landing confirmed.
But
Discovery,
the
go
engine
and throttle
purge
up.
down snuffed that flame out real fast. So when engines when you shut off a rocket engine, they usually purge them out with helium. There's a very good reason for that. Well, one, because you don't want to get a combustion byproduct. Throttling down a rocket engine, you can sometimes some fuel and oxidizer get stuck in the lines. Well, not stuck in the lines. It's still in the lines. It's like if you have a garden hose and a sprinkler, right? You turn the hose on, it fills the thing up with water, and the sprinkler goes. If you shut the hose off, the water is still in there, right? It's not just going to evac all the water out for you. And then you go to wrap the hose up on your arm, and you get all freaking soaked from it. Rocket engines are kind of like that because it's plumbing at the end of the day. Hey, Postal, 41 months. Thank you. So
Deploy.
what happened here is some of that residual got stuck in the gas generator. So the gas generator is the jet engine that's attached to the quote unquote jet engine that's attached to the side of the Merlin engine. It's a jet engine, and the jet engine is driving the fuel and oxidizer pumps, the impellers. And it dumps out extremely fuel-rich soot. That's actually the soot that gets thrown onto Falcon 9. It's actually not byproduct from the engine. I mean, it is a little bit, but most of it is from the generators. The generators are shooting out soot like crazy. SpaceX, for cooling purposes, keeps the gas generator running very, very fuel-rich. They spray a ton of fuel in there, and the fuel actually absorbs a lot of the heat from the combustion. So they spray way more than they need to, and they end up using it using the extra kerosene, the unburnt kerosene, to absorb the heat. A lot of rockets run stoichiometric for thermal purposes, like to keep the thing cool, because like the weird thing is that it's not really weird. That fiery stuff that comes out of the bottom of a rocket engine, it's hot, and the key is to get it just cool enough to where like a metal would work. So it looks like, once again, we got a little bit, the gas generator exhaust, that leftover crap that was in the leftover propellants, leftover commodities inside of the engine, did catch fire here. It did burn something, and the flames do look kind of a little green, but I think that might just be the camera. That light looks green to me, but I don't know. Maybe I'm not the best one.
Stage 1 landing confirmed.
And then, yeah, see, it caught on fire, and then you could see that Falcon 9 purged out the E9 engine with helium. You could see the helium gas coming out right there, and it immediately snuffed the flames. Yeah, so T-Man, that's fine. Yeah, it's nothing, dude. That's normal. I don't think there's any damage to the engine. I think it's just the camera lens.
Stage 1 landing confirmed.
The camera lens and the exposure. Because, like, look at these flames here. Those don't look as green as those do.
Stage 1 landing confirmed.
See, this is a white light. Combine it with a yellow flame, right? Like, yeah, I don't think that was green at all. I think that's just the lighting, just the camera exposure. But yeah, that was the Starlink 648 mission from last night. Everything went well. It was the second flight for booster 1083. I'm not even sure. What is that? The newest Falcon stage? That might be the newest. Here, let me go and take a look. Let's go. 1084 is the newest one, and it's a Falcon Heavy core. Nope, 1084 was expended. What's the most active? 1086 and 1087 are side cores. 1083. Wait, where's 1085? Huh. Tesla, this spreadsheet is just annoying. Interesting. Yeah, Starlink 648. See that? That was the second time that booster's been reused. 37-day turnaround. Yeah, I know. You could do 1085. Why is there no 1085? Huh. Huh. There's no 1085. I wonder why. Maybe it's a Falcon Heavy center core. That's the only thing I could really think of. It's got to be a center core, right? Because there's two Falcon Heavy side. Oh no, the core is right there. I am super confused. That's very weird. Then maybe they said no. Maybe they said no. Skip this number. Frick that number. Huh. Yeah, I just did. Oh, Forrest, there's nothing. Maybe they scrapped it. Maybe they didn't like it. 85 is an unlucky number on Mars. Is it, Matt? I don't know. Is it? I don't know what's going on here. Got him. Super sneaky launch? Maybe. Oh, this is cool. Booster turnaround time. Dude, look at the rates on these newer ones. These newer ones definitely have a much quicker turnaround time than some of the older ones. Like, look at 1058 and 1060 take some time. But you don't see any big gaps over here with these guys, huh? From like 69, nice. From 69 forward, those ones, 71 to 81. Those guys right there, those things can turn around real quick. That's crazy. Yeah, Governor, it could be the second, it could be another Falcon Heavy side. Yeah, you're not wrong. Yeah, see what I mean? SpaceX is getting better at making these boosters. Like, this just shows that, like, Falcon 9, they're still working on it. They're still upgrading it. They're still, these are just called operational improvements, though, in systems engineering. This is just something akin to like an Army field modification or something. Like, this is something, these changes that are being made up here are all for getting your turnaround time down. Like I said, look at some of these. Look at how long these turnaround times are here for like 1048, 1049, 1052, right? Even 1058, the worm, right? Some of them are, see what I mean? Some of those gaps are really, really high. But then again, that could be for other reasons. But these things get turned around in about 40 days nowadays. Person didn't get better at making graphs. Always label axis. Yeah, right. Yeah, for real. Full thrust booster flight counts. Huh? It's limited to the full thrust versions. Oh yeah, those are FD Block 4s. Most of those things were junk. Whoa, dude. Look at this graph. It's 48 and 49 days, huh? I don't think so. Jeez. Look at this. Unreal, dude. That's crazy. It's just off the wiki page, dude. That's nuts. Look at how full this graph gets. The chart is days on the x-axis. I understand that. but if you hold over here, see, look, it'll tell you exactly what's up. Do they retire the boosters or don't use them until they work or explode? I don't think they know where the upper limits of the booster reuse is, Sig. So I don't, I think it's fly it until it breaks right now. And then when they find an upper limit, then they might start retiring it as they build new ones. That's a screwy graph. If you hold your mouse over this, you can see the time between refurbs. See what I mean? Anyway. Look at that, man. Look at how complete this is up here. Especially some of these guys right here. I could see them pulling one out of service at like 30 flights. Man, yeah, dude, like Tesla, we don't even know if they're doing that to one of these. Like, what if they're doing that to 60? 60's at 20 flights, is it not? Let's see. Let's take a look. Oh, it's at 19. Yeah. Not at 20 yet. 60 and 61. Huh. And maybe they'll do it at 20. Who knows? Wait, 62, 61, and 60 are all at 19 freaking flights, dude. 63 is at 17. And 67's at 18. What the? How did this happen? How did? Jeez. That's crazy. Anyway. Yeah. The highest serial number for a Falcon 9 is 1083. There's been 83 Falcon 9s. Huh. That's a lot. I remember when Booster 19 landed. I'm like, damn, dude. 19, they've made 19 of those. That's crazy. You know, like, and they got one back. Yeah, that's pretty awesome. All right. Anyway, that was the Starlink launch from last night. Now, there's a video from Rocket Lab here about Launch Complex 2. So let's see what's up. 1082 is flying tomorrow. There you go.
For a whole suite of various government or defense companies to be able to launch from American soil means they can actually launch a more diverse set of payloads than they can if they're required to actually export them for launch. And for us, it's great. We can leverage all the resources we have, but provide that expanded capability to launch different types of payloads from here on American soil. So we've got a great established relationship with the NRO. This is our 5th launch with them. So at this point, we know them and they know us. But this is our first chance to launch them here from Virginia on American soil, which is very exciting. So it's really nice with those guys because they know our process. They know how we do things and how we do things efficiently and quickly. So anytime anything comes up where we have to modify anything to support their payloads, they know how to ask for it and we know how to provide it very efficiently. We want it to be very quick from signing a contract to getting you on the launch pad and launched, especially with national security interests. So we need to have that responsiveness, and adding a reliable vehicle like Electron that the entire government community can use really adds to our ability to be responsive as a country and as smaller communities within the government. I'm a sucker for a good team. That's really what it comes down to for me. So, you know, we've got so many people that are here to support launch, and everything has to go right. And so to make that happen, you need to have a bunch of people who are really good at their jobs, and launch day is when everyone gets to show what they do. So people who are really detail-oriented, they've done their homework, they're really enthusiastic and curious and driven to do as great of a job as they can do, they get to put their cards on the table and show that on launch day. So it's great to see a high-performance team absolutely operating at their peak on launch day, and there's just that excitement in the air. It's almost like an adrenaline rush that you really can't get in other fields.
So that's their new launch complex. It's well, yeah, pretty new. That's their new launch complex down in Virginia. It's right here. There's Antares' pad right there, and then Neutron, Rocket Lab's next generation rocket, it's bigger, is going over there, which is pretty sweet. That's pretty cool, man. This is just a video about how like they launch NRO payloads and stuff. But there's the transporter. There's 4 hold down points down there, and then a fuel line, fuel and oxidizer line, and then you got another set of fuel and oxidizer lines right there for the second stage. There's the clamper arms, and then there's your payload fairing umbilical right there. I like it. It's sleek. Very nice. Do you think Wallops has enough room for a Starship pad? Yeah, I mean, I guess. Yeah, I mean, sure. Yeah, soapbox. I don't think they'll ever. I mean, okay, you should never say never, right? But I don't think they'll put one at Wallops, dude. I think by the time they're thinking about expanding Starship to other launch sites other than Brownsville and the Cape, I think they'll start building floating platforms and that's based off of what I saw from the Starship All Hands meeting that we watched yesterday for Space News. But with that being said, you should never say never, right? Hey, DV13, what's going on? You should never say never. Like, you don't know. You don't know what Starship's going to do. You know, like if you told somebody in the United States in 1939, right, that in just 10 years, flying boats would be stupid. Like flying boats would be completely irrelevant. They'd look at you funny. The reason why is because that was the way to travel by air. Well, why? What do I mean? What do I mean? Was that was the way to travel by air? Guys, planes landing on concrete and asphalt and like flat runways was not seen as the right idea up until after World War II. The best way to fly around was just to put a dock somewhere and have a seaplane just go into the water and take off. Why? Because there's plenty of ocean. Why would you clear like a gigantic field and then pave it, right? That's way too expensive. Why would you do that when you could just buy a flying boat and fly around and use the boat? That way the water is your runway, right? Why would you do that? But then, World War II came around and defense spending went through the roof and airfields were made pretty much everywhere in every freaking town, right? And then after that, flying boats were irrelevant because why would you make something that goes into salt water? We have all these runways. Just make it land on land, right? That's why flying boats went the way of the dodo, right? So why do I bring this up? Well, I bring this up because, it seems absurd right now to go and build another Starship pad at Wallops. Like, why would you build a Starship pad there? Why would you build a Starship pad at Vandenberg? Why would you do that? That seems weird. But just because it seems weird right now doesn't necessarily mean that that wouldn't be a thing in the next 5 years, right? Just like a flying boat became instantly irrelevant after 1945, right? Yeah, Deadbringer, right up until World War II, there wasn't any point in trying to make planes that land on a nice flat surface because no one's going to build airports everywhere, right? Just like right now, it doesn't make sense to build Starship pads everywhere. Like, why would you do that? And, I hope the reason why we don't build more Starship pads is because of a war or something. That would suck. But, Starship could change the game like that. Without, minus the war part. We don't want that part. That part's bad. You don't want that. Military shipments, maybe. It's possible, Pete. Yeah, I just really hope that, defense spending does really, 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 really make some nice make for some nice aerospace innovations. In fact, every time we dump a bunch of money into defense, we usually get something pretty cool. You know, like pressurized cabins or something. That was something that came out of World War II that's kind of useful nowadays. Did you see the Sierra Space video? I did. So what is the future for Slick 6? Falcon Heavy, I believe. Flying boats look pretty amazing though. Yeah, you're not wrong. You are not wrong. The H-4 Hercules is my favorite flying boat. Elon said thousands of starships. That means thousands of pads. I don't think it's necessarily 1-to-1, Raiden, but I'm guessing that's some hyperbole on your part. You're getting at we need more pads, right? We're gonna need more than 3. We're gonna need more than 4, right? Is that what you're getting at, dude? Because yeah, I mean, yeah, I don't think we need hundreds of pads for thousands of starships, right? Just like we don't need, if you have thousands of airplanes, you don't necessarily need 100 runways, right? Because the pad, like turnaround on the pads, right? But I don't think it's 1,000 to 100 necessarily. Maybe like 1,000 to 10 or something. Sea launching could make a comeback. Yeah. Yeah, radar, jet propulsion. Yeah. Let's just hope that Starship doesn't let's just hope that Starship doesn't, end up becoming like a thing because of crazy defense spending, because fighting, that would be bad. That would be bad. That would be bad. I don't, maybe T-Man, who knows? Maybe. Point to point is still a long way off. Anyway, we'll talk more about Starship here in a little bit. I do have some actually pretty interesting news here. This is coming from Jeff Faust over at Space News. Take a look. The ESA awards a contract to Thales Alenia Space to restart ExoMars. That's good. ExoMars was a program that the U.S. and the ESA were working on. And then the Americans pulled, we defunded the program. I'm not sure why we did that. And so the Europeans tried to work with the Russians on ExoMars. And in 2022, they decided not to. And they canned ExoMars in early 2022. And now it looks like they're trying to start ExoMars up again. ExoMars is a Mars rover project, which is good. That's a good thing. Yeah, that's a good thing. We want more science payloads, so that's good on the Europeans for getting that thing up and running again. It was supposed to launch in 2022, but yeah, that didn't happen. Yeah, that didn't happen. I doubt it, T-Man. This rover went from flying on Soyuz to Atlas V to Ariane 5 to Proton, now back onto a U.S. rocket. Who's launching it? Let me scroll down in here a little bit. ExoMars will also incorporate contributions from NASA. NASA will provide aerobraking engines, RHUs. NASA will also provide a launch on the mission, currently scheduled for the fourth quarter of 2028. Nguyen Xuanda said NASA is currently procuring a launch vehicle for ExoMars, but it has not selected one yet. I think you need to log off at 9 today for Fallout. Oh. All right. Yeah. I could probably get that done. Are there any launches tonight? Just to be sure. Nope. Angara scrubbed again this morning, actually. How far into the program were they when they got canned fully? It was scheduled to fly in 2022, so very, very far into development, Shaw. Yeah. Interesting. Interesting that it's come full circle. But it's good to see funding for science, for scientific programs happening. Those are the precursors to to getting people there. The more rovers that us and the Europeans and anybody can send over to Mars, and as long as they're willing to share the data about it, we could learn something, and that would help us get people there eventually. That's good. That's a good thing. So yeah, interesting stuff. It did come full circle. So next thing is coming from relativity here. This is relativity space. POV, rejuvenating 60 years of history at the A2 test stand. Yeah, relativity's got the A2 test stand at Stennis. Oh, that's cool. This is a monolithic test stand that was used for testing Saturn 5 second stages. You could see this circular bit right here is the pedestal where they would mount it. Here, hang on. I'm just getting us a picture here real quick. So this is what the A2 test stand looked like back in the day here. Let me get a picture. Oh yeah, that's a cool picture. You guys will like this picture. I like this picture. This is a nice picture. Oh. Hello. Oh. Fall, you're photographing at a STEM festival this weekend. It's kids from all over the country. Should be a good time. Nice. How many ships would be on that giant convoy to Mars Elon was talking about? Yeah, that's right. That's right. So 100 pads might not even be enough. Now, Raiden, here's the real kicker. Yeah, you're probably right. Here's the real kicker. Where are all these pads? Cape? I mean, I would personally probably want most of these pads closer together. I think they should be near each other. Just in case one pad goes out, you can just pick up a super heavy and put it on another pad. Ocean-based? Hands? Yeah, that's the original A2 test stand. And then they took the test stand and refitted it for shuttle engines by putting fuel tanks up there. That's what it looked like during the shuttle program. See, they had a hydrogen and oxygen tanks up here, and then they used it for engine testing along with the A1. The A1 is the Fred Hayes test stand. We'll talk more about that in a second. But Relativity has it, and they're going to use it to test their... it's once again going to return to stage testing and not engine testing. It's going to return to stage testing, and they will be testing Terran R, their reusable Falcon 9 competitor. Come on, guys. You got any better pictures of that test stand? Y'all got any more of those test stands? Y'all got any more of those test stands? Y'all got any more of them test stands? That's good enough. Off topic, in all your KSP wisdom, do you know the field of view of the camera? No, I just hold Alt and change it until I like what I see. Here's a thought. Sun-synchronous staging orbit for interplanetary transfers. You could launch said orbit from all pads all over the world. Yeah. Which test stand did they use for shuttle testing? A1 and A2. And then the B2 test stand was used for the shuttle main propulsion test article. I want at least 6 land-based. Yep. Oh, man, that thing is cool. Dude, it's a monolith. That thing is huge. Look at that thing. There's one of the old shuttle engine tanks right there. But yeah, this thing had a giant opening on one side, so the crane could lift the S2 Saturn V second stage into place, and then they just set it down right here. They set it down on the S2 aft skirt and hook the thing up and send it, which is freaking cool, man. I mean, if you look at the cars in the background, look at the people walking around here. That's not a small test stand. It's not as big as the B2 test stand, but it almost is. It's got and this right here, if you're wondering what this is, that's a flame bucket. It's not a flame trench. Flame buckets and flame trenches are different. Flame buckets basically don't shoot into a trench. That's it. And this thing has pipes built into it to pump water through it to keep it cool when it's taking the brunt of rocket engines. Yeah, look at the people in the stand. That's right. Yeah, pretty freaking cool, man. I'm sure, Alex, I'm sure SpaceX is thinking about that, dude, for sure. Can we go back to building big, cool stuff like this? I mean, the OLM and everything is sick. Don't get me wrong. I like that. But can we go, like, can we, I like all the Starship stuff. The Starship stuff is amazing. I want more of that. But I also want more of this, too. Is that bad? Can we make, like, a super heavy engine test stand or something? Oh, jeez, I wonder what that would even look like. Why are there lifesavers on the railing at the bottom of the stand? This is a barge. Good question. This thing right here, that's the edge of a barge. Yeah, the forklift is on, and the S2 carriage right here. It's a barge. Because they can't truck in something that big. They can't truck in a 10-meter core. So yeah, they had to bring it in via barge. They have the this crane right here, right? So they'd roll this thing into position. The crane that says American on it would attach to the back. You can actually see where it attaches, right? There, see? So they would put this thing on there, that bracket. It would bolt to the skirt, which is the strongest part, the aft skirt, which is the strongest part of the S2, right? And then they'd put the cap up on the top here, which is attached to the forward skirt, which is the second strongest part of the S2. The reason why this is stronger is because this has to take the brunt of the first stage pushing up on it. This, kind of. I mean, it still kind of does. That's more chunky than that thing, though. But anyway, so the crane that says American on it would attach to the back here, and then this big boy up here would attach to that top piece. And the two cranes will tandem lift that stage up, and then the first crane will start lifting, and the second crane will just kind of sit still. And that will rotate the stage up, and then when the stage is vertical, they'll detach it, and then it lifts it up and puts it on the test stand. Yeah. They did that with the SLS core stage. It's basically how the SLS core stage was put together. Super freaking cool. But yeah, that's what the A2 test stand was supposed to do. But here's the thing. Relativity is going to revert it to looking back to looking like this. It's going to be a stage test stand again instead of just an engine testing stand. You can see those cranes probably got used about 4 or 5 times, like not 4 or 5 times, maybe 20 times, and then that was it. Stupid. Oh yeah, NASA built 2 of them, by the way. The A1 and the A2 test stand they're very similar. Need more rocket. It's so lonely here. I'm sorry, DV. Here, I'll say hi over in the YouTube chat. Yo. You decorated one of your bathrooms with John Krause's launch photos. I call it the Flame Trench. Okay. Yeah, Red Fox. Well, Von Braun engineered out the Apollo program to not be a 10-year program. When they did all the systems engineering and all the facilities were built out for the Saturn program, they built these test stands out to be used a lot. They built them out. They built those test stands to be testing Saturn V stages every day. Just like McGregor tests engines every day and stages every day. That was the whole point. That's why the B test stand is a 2-celled test stand, because it's supposed to be able to test fire two S1Cs back to back. Yeah, 2 Saturn V first stages. The A1 and A2 test stands are S2 test. They're both S2 test stands. Actually, I think it's S2 and S3 tests, or S2 and S4B test stands. I think I'd have to go look. Anyway, yeah. EJ talked about Stennis without the test, without the rant about the test stand that never got used. You want to hear something funny about that guy? The A3 test stand? They gave it to Rocket Lab. Which is not a bad thing. But they let Rocket Lab lease the test stand for vacuum testing for the neutron rocket propulsion. And now NASA needs a vacuum test chamber for upper stages. They're retooling the B2 test stand. They're retooling the B2 test stand for the EUS for their upper stage. So the A3 test stand is getting used, but it's NASA. What I'm trying to tell you is that NASA leased it out, and then they realized they needed a vacuum test stand, which is okay. Okay. But I do have actually more news coming from Stennis if you guys want to hear it. So here's a good view of the complex. Yeah, they do. Yeah, here, we'll look at it real quick. I have more news about Stennis, but here, I mean, yeah, this was all built out to basically run the space program for decades. You could just keep launching Saturn V's. They built out all the infrastructure to scale up. That's why the VAB has 4 high bays in it. That's why there's 2 launch pads. That's why 39A and 39B. That's why they built that's why they built 2 of them with the plans to build a 3rd one. This was designed to basically bolster NASA's space program for decades. That was the genius of Von Braun's project management. The guy was one of the most notorious and legendary systems engineers out there. Yeah, by a long shot. This stuff was built to do work. Stennis was built to be like McGregor is, guys, with Raptor engines. There's like 4 or 5 Raptor engines going off at McGregor, Texas for SpaceX like every day. They're doing tests every day. Stage testing, upper stage testing, vacuum testing, Raptor testing. They have like 6 Raptor stands out there. That's what Stennis was built for the Apollo program. It was built there to just put every S2 that came off the line, you put it on here, you do a full duration burn with it to make sure that it's good. SpaceX does that with first stages. Should have done that. Like that they should have done that with the Apollo program. It would have been excellent. But yeah, even the Saturn V second stages on the B2 test or first stages, the B1, B2 test stand where they did the green run, where NASA did the green run, was designed to be able to hold and test fire 2 Saturn V stages, not at the same time, even though that'd be awesome. It is a monolithic piece of equipment. There we go. See? Look. It had one crane here And one crane, you know, the crane isn't installed on the other side in this picture because I don't think the left test stand, the B1 test cell is ready to go in this picture. It's still under construction. The other way to tell that it's under construction is because that Saturn V doesn't have engines attached to it. He also seemed to know that the money would eventually dry up, so he built it for what he could imagine, not what he could actually get authorization for. Yeah, exactly. He built it while they knew they had the blank check. And what do we do with it? We built a space shuttle. Don't get me wrong, I love the space shuttle, but I'll take that. I'll take that. That's fine. Yeah, look at that thing. That's awesome, right? I think that's really freaking cool. Also, there's some wicked nice cars there, guy. All right, what do we got here? What do we got? Country Squire, another Country Squire, Volkswagen Beetle, another Volkswagen Beetle. 54 Chevy. Chevy C10 right there. What else is back there? That looks like an Oldsmobile, but I can't tell. And that looks like a Mustang. Nice. Nice. 2 Country Squires. Cool. No, Reginald, I disagree. I mean, dude, look at the flame bucket. Look at how much beef is built into the flame bucket on that thing. The flame bucket's being held up with concrete supports. The other ones are just metal. They're just straight metal. That one is designed to hold 7.5 million pounds of thrust and then some. Look at how chunky it is. That's awesome. What about the thing to the right of the 2 figures? That is a World War II military truck. I forget the name of that thing. I always forget its name, but NASA bought a bunch of them. And they used them for just towing stages around. Oh, that's a light. Oh, that's what that tower is. It's for lights. So you could do night operations. That's a huge spotlight. Cool. Actually, you know what? You don't need another one of these over there. You can just you could rotate over here, and that crane could put, once the thing's vertical, you could put this over there or over there. You could put it on B1 or B2. I don't think they ever used the B2 for firing Saturn V stages. I don't think they ever used it. Or the B1. B1 ended up being used for RS-68 testing, but yeah. Yeah, one of your favorite parts is checking out the old cars. This picture is from about 15 years ago, I'd say. So let's see. Are there any cool cars here? Ram 2500. GMT 400. 10th gens. Bronco 2, though. Bronco 2. I really don't like looking at pictures from my childhood and picking out cars that I want. That's really not cool. Really don't like that, but I'm still doing it because the cars. It's all about the cars, man. Yeah, see, somebody asked, Canuck, I think you asked about the life preservers. See, there they are. Because the barge was right there in the other picture. That other picture was taken from over there. I just arrived. What the heck is that giant thing? Looks like a World War II U-boat bunker built with more stuff on it. These were test stands for the Apollo program, and then later shuttle engine test stands. It's the A1 and the A2 test stand in Stennis, Mississippi. Yeah, they were built for... Here, hold up. I can show you. They were built to do that. To test Saturn V second stages. The reason why we were talking about test stands in Stennis in the first place, hold on one second. Ranchero. Tornado. Very nice. 2 C10s. C10 step sides. Cool. Beetle. 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 An Econoline. Nice. Nice. I'm not sure what that is. I can't tell. Maybe Pontiac Tempest, maybe? Anyway, the reason why we're talking about this in the first place is because Relativity is leasing the A2. Is it the A1? Hold on. Excuse me. I think it's, I don't know. Hang on. Give me 1 second. Give me 1 second. Now I forget which one it is. Because A1 and A2 are identical. It's the A2 test stand. See? There you go. They posted this picture, which is really cool. They took the flame bucket out and they're refurbishing the flame bucket. But you can see right here, this chunky cylindric piece is where the stage attached. Nope, not that one. That's where the second stage attached to it. I hate you, Mark. I hate you. I'm gonna lose my mind. I'm gonna lose my mind. Bree's on the phone. Why does she always call when I'm having a problem? What? Yeah. What do you want? You're on stream. What's up?
I was gonna watch Wonka and then I realized you might want to watch it, so I'm calling to ask if I can watch it or if you want to watch it.
Watch what?
Wonka.
I don't want to watch that.
Okay. Alright, that's all.
All right. Bye.
Bye.
Love you too. Leasing it still have to bring their own crane. Do I already have it open? Yeah, there it is. There it is. You could see where the attachment ring where they would attach the aft skirt, which is pretty sweet. Yeah. Pretty cool, man. I'm just happy the stand is getting used. It's interesting because behind this picture of the team that's working on the construction, you could see the well, we know when that picture was taken. Reddit said it was good, so you figured you'd try. And yeah, see, there's that picture of the A3 test stand. Rocket Lab has that test stand over there. Do you see any? Oh, there's some activity going on over there. Not bad. That's a vacuum test stand that was built for the Apollo, or not Apollo, for the Constellation program. But NASA built it, canceled the program halfway through construction, and the contractor sued them, and they built then to finish the construction. Contractor finished the construction 3 years after the program was canceled. Yeah, you remember when I said being a spaceflight fan in the early 2010s was a really, 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 really crappy time to be one of, yeah, there you go. Yeah. I'll say that one more time just in case anybody's wondering. The A3 test stand that was built for the Constellation program was completed in 2014, 3 years after Constellation was canceled. Because the contractor sued NASA and said, look, I've already invested in this. You're paying me to build this test stand because I'm halfway done with it, and you're gonna finish it. You're gonna pay me to finish it. You can't renege on your contract. And NASA's like, yes, we can. And he's like, fine, I'll take you to court. And he won. Oops. Whoopsies. Is it for a full stage or just engine in the vacuum? You know what, Zombie? I'm not 100% sure on that one. I know it was for J2X testing, but please hold. Maybe we could use this as an opportunity to learn. The A3 test stand was originally designed to test fire the J2X engine at a simulated altitude of 100,000 feet. It features a test cell that is 66.3 feet high, so 30 meters, by 40 feet, which is 12 meters. The primary structure is an open steel frame rising to a height of over 150 feet. That's a 15-story building and is designed for thrust levels up to 1 million pounds of force. At that point, we should have just built the stick. Yeah, I'll say it once, I'll say it again. Constellation was not behind schedule. It was not behind schedule for any other reason than it turns out that if you don't give NASA any money, they're gonna fall behind schedule. They got rid of the program because they said it was underperforming. If I was your boss and paying you $50 an hour to do a job and you did 8 hours of work, right? And I said, sorry, I can't give you $400. Best I can do is $100. You would underperform too. You'd be like, okay, no, yeah, and then that would be like me saying, well, you're not performing to what I asked, so I'm gonna fire you. And you'd be like, yeah, you're firing me because you underperforming. Yeah, it was stupid. Yeah, that was dumb, and I'm getting annoyed thinking about it. So, next bit of news. Yeah. All right. What's the next bit? The next bit actually has to do with Stennis again. Here, check this out. This is over on the A1 test stand, the Fred Hayes test stand. This is pictures of NASA pulling an RS-25 off of the test stand here. Yeah, no, Aqualex, it's bad. I don't need any more analogies. I'm starting to get annoyed, and I don't want to get annoyed. Hey, funny you, what's going on? Over on the YouTube side of things. Thank you. How you doing? Sorry, it took me a second to respond. Reading this thread on my commute back gave you PTSD. Okay, I'll look at that. I have it up. I'll look at it. So this is a motor that they took off the test stand here. This was the one that they were testing a lot. This is a test mule engine. RS-25 developmental engine E0525 was removed from the Fred Hayes test stand on April 9th. Following completion of the second and final 12 test series for lead engine contractor Aerojet Rocketdyne and L3 Harris Tech Company to certify and build RS-25 engines for SLS. What's the coldest part of the RS-25 when firing? Probably the high pressure or the low pressure hydrogen turbo pump, if I had to guess. One of these things up here, or that pipe. Yeah, Aerospace. The RS-25 is a great engine. Great engine. You know what? Maybe I'm a little bit cynical. Maybe. I'd like to think that I stay pretty optimistic when it comes to spaceflight stuff. But also, that RS-25, E0525, they put that on the test stand and fired it like every other day for a month straight. The engine that they said was not refurbishable, and you had to take it apart after every flight when the space shuttle fly. I'm not upset. I'm not upset. Maybe every other week, but close enough. I'm fine. Yeah, Urban, you're right. You're right. Don't go down this road again. It only leads to pain. You're right. You're right. You're right. You're right. You're right. Smile and wave. The engine that they said was not reusable, they're reusing on the test stand. I know they're reusing it because they couldn't take it apart when it's on the test stand because it's mounted. You can't take it apart when it's there, which means they didn't refurbish any. They didn't take the entire engine apart between test firings, which means that it is reusable, and NASA just never bothered to. Oh. Okay. Okay. That's fine. Yep. Can we see the differences between the old one and the new one? Not really, T-Man. They look very similar. Eject. Eject. Yep. No, it's fine. It's fine. It's fine. It's fine. It's fine. Everything's fine. I'm good. It's fine. You good? No. No, I am not good. I'm not good. Shuttle engines were reusable. They just never decided to do that under the guise of safety. I am a bit disappointed. And if it's one thing I do not like to be, it is to be disappointed. I know. Anyway, race car seats versus aluminum ones. Okay, I don't know what that means. All right, sweet. Deep breaths. Deep breaths. It's fine. It's fine. It's fine. All right. Anyway, so yeah, we're now leaving Mississippi and we are going back to New Zealand. Here, let's see. This is another post from Rocket Lab here. And Forge, we'll check out that thread that you linked here in a second. This Electron has been to space and back. Now it's getting ready to go again. For the first time, a recovered Electron stage has been returned to the production line to undergo final acceptance and qualification testing in preparation for flight. Yes. Sorry, sir. It'll never happen again. I know. Beep. I'm still waiting for pictures of the Soyuz seat integrated inside Dragon for Mark when Soyuz had that leak. Huh. Did they do that, Forge? That's super cool, actually. Human rating makes you do funny things sometimes. Yes, I know. Okay. Daily Space News, what kind of witchcraft is this? We're getting back into the groove, Zay. We're bringing the band back together. Tell your friends. You two girls, tell your friends. The Space and Rocket Review. Bringing the band back. We're putting the band back together. Come on, we need you, man. We need your horn. If you say no, me and Yarg will come here for breakfast, lunch, and dinner every day of the week. One night only, the Blues Brothers Rhythm and Blues Review. Oh, we got both kinds of news. We got space and rocket news. Welcome to EJ's Country Blockhouse. Yep. Does this mean KSP mission mode is coming back? Hey, let's not get a little bit too ahead of ourselves there. Rawhide and A. Rawhide. Rolling. Keep them doggies rolling. Rawhide. Load them up. Bring them down. Load them up. Bring them down. Rawhide. Anyway. 4 attachable SRBs in a core stage. And a high Delta V upper stage. You want Carolox or Methalox? No, ma'am. Dry. Yes, they installed the Soyuz seat inside a Dragon for Mark Rubio when Soyuz had that leak, and it can only support 2 people. Really? Huh. It's Frank Rubio, not Mark Rubio. But that's cool. Oh, okay. It was just for an emergency thing. Got it. Anyway. All right, Forge, what's this thread you want me to see? I swear if this is clickbaity, I'm gonna... Oh, no. Do I have to look at this? All right. What is this? What is this? Everyone knows about the space shuttle disasters of 51L and 107, but did you know there were many near misses through the program? Yes. SDS-27. Nathan, how you doing, buddy? Let's talk about it in this thread. Yeah, SDS-27 was not good. Not great. An SRB parachute, or no, separator motor. Or no, was it the parachute or something on the front part of the SRB? It was either the parachute motor or the separator engine fired way too early and shot like right into the shuttle's thermal protection system. Yeah, that's about as good as that ended about as good as you think it did. Yeah, not good, not great. Crew miraculously made it back because there was a structural piece in place where the thermal protection system had a hole in it. And that actually made it so it didn't engulf the crew tank with fire. Yeah, during re-entry, yeah. All right. The two near misses are relatively well known, 27 and 93. However, these are only 93 is not as bad as 27. They're only scratching the surface of the issues that haunted the shuttle throughout its entire career. Here's a non-exhaustive list of all the times the shuttle nearly experienced some sort of threatening failure or came close to doing so. SDS-1, overpressure wave damaged the body flap of the orbiter. That's correct. That happened. Landing gear cover warped due to thermal damage. Many missing tiles in non-critical areas. Yeah. The SRBs overperformed. And they reverberated off the off the mobile launcher platform. And they did shake some tiles off of the OMS pods. But they were in non-critical areas. That was quickly remedied. I wouldn't really call this, that was a test flight. So this kind of stuff is the stuff you want to figure out during a test flight. So, okay. SDS-2, fuel cells failed, leading to a truncated mission. SRB seal anomaly. What's SRB seal anomaly? What does that mean? What is an SRB seal? They're O-rings. I don't know what that, are you talking about blow by? I would assume maybe that. Did they overperform equally? Yes, Erudite. Yep. They actually gave too much thrust. It lofted the trajectory, but the shuttle's redundant set launch sequencer took control of it. The auto sequencer, the shuttle's avionics compensated for the overperformance. That does happen. That's something that we don't really see too much. And the reason why we don't see it is because we don't have a lot of rockets telemetry. If I had the telemetry in front of me, I could tell you what rockets overperform and which ones don't. Sometimes they do. But that's what closed loop guidance is for as well. Closed loop guidance can compensate for over or under performance within a nominal range on the first stage. I've seen it happen before. I haven't said anything though. I've definitely seen it. I can recall a Rocket Lab mission where the second stage had to like turn radial in because of overperformance. We've also seen a ESAB on Ariane 5. The Ariane 5 upper stage, I think, is ESAB. We've seen that thing overperform a couple of times, actually, and then it compensated. And we saw the convergence on the telemetry for the compensation, like by burning radial in because of overperformance. It's definitely happened. If I see it during a launch, I'll point it out. But yeah, it's really hard to see without telemetry. We've seen Ariane 6 underperform a lot too. Yeah, it hasn't even gotten to closed loop guidance yet. SDS-6, more than acceptable tile loss and thermal damage. SDS-9 landed with an APU on fire. SDS-41B, a chunk of frozen piss struck the OMS pod of Challenger, leading to significant tile damage. That actually happened. They had to scrape the They had to scrape it off with a robotic arm. That's actually a thing. Yep. That's actually right. Yeah. The shuttle has a dump at the very back for the waste systems, and they did it too quickly. And P immediately, like, you know what happens when you push liquid at pressure into the vacuum? It'll immediately solidify in the like split second where the temperature drops to nothing. It'll solidify immediately, and it actually clogged the piss pipe. That actually happened. Yeah, that's right. Piss struck the Ohms pod at Challenger, leading to significant tile. Dude, it didn't damage it as much as that implies. It was. Yeah, they were more worried about having it attached. I would say having a big piecicle on the back of your space shuttle was probably is probably a little bit more dangerous than a couple of dents in the Ohms pod tiles. APU on fire sounds bad though. I'm not familiar with that one, to be honest with you. I've never heard that one. What else? 51D, left outboard Elevon experienced significant burn through during re-entry. Right brake failed on landing, leading to tire blowout. That happened. You're Ryan. Yeah. 51F, center SSME shut down 5 minutes into flight, resulting in an abort to orbit. Yeah, but that is right. That did happen. We're just not gonna mention why it happened though, huh? That's not even close to a near miss. That STS-51F actually used the Ohms pods to compensate and actually ended up doing a full duration mission. The reason why the center engine shut down, it's the only time there's ever been an abort to orbit with the shuttle. The shuttle's flight computers compensated because one of the engines shut down. Now, why did it shut down? Bad sensor. Engine was performing just fine. Yeah. There's a bad sensor. That's not even close to a near miss. That's good engineering. Because the other two engines compensated. Challenger went into an aborted orbit and then used the Ohms pods to correct, which is exactly what it was designed to do. I wouldn't even call that a near miss. That's just good systems engineering on the shuttle's part. 61C. An error during fueling led to the drain back of 14,000 pounds of LOX from the ET. If this had gone unnoticed, the shuttle would have been forced to perform a transatlantic abort. What's up, Ian? Right before landing, 2 of the orbiter's 3 auxiliary power units caught fire due to a hydrazine leak, but the orbiter nonetheless landed successfully. See, Tessa, I wouldn't even call that a near miss. Yeah, it's on fire. It's not going to stay on fire. You'll burn off all the hypergalls and maybe damage some things, but these things are already designed to be hot. It's an APU. Now, with that being said, 2 of the 3 caught fire. Well, I would say that's pretty good. That's pretty good analysis on your engineering to put 3 of them on there. They made them triple redundant for a reason. Just saying. Shuttle has 3 fuel cells on it, 3 auxiliary power units, and 3 hydraulic power units, all in triple redundancy, and 3 engines for triple redundancy as well. Remember that whole part? Yeah, I'd say that's damn good analysis done on the shuttle engineer's part. I'm just putting it out there. I'm just playing devil's advocate here. All right, just putting it out there, man. The leak was discovered after it burned itself out and caused damage to the interior of the compartment. That's the orbiter aft main compartment. Yep. The shuttle was then sent off for an extensive renovation and upgrade to bring it up to date with the newer orbiter as well. Yeah. Yeah, yeah, it's a great engine. We know it's a great engine because they just put 0525 on the test stand and fired the trash out of it without refurbishing it like 12 times, and it's fine, which is really annoying. Yep, I'm back to that. I'm back to it. I'm back to it, man. I'm not letting it go. Not letting it go. Yeah, Dead Crew. Yeah, exactly. I'm not letting it go, man. That's bullcrap. Eject. No, I'm not ejecting. I'm not ejected. There's no ejector seats. All right. Shuttle didn't have them past flight 4. Okay. Yeah. SDS 27. Yeah. That almost. Yeah. Yep. 700 tiles damage, 1 missing, and just nearly disintegrated, but was saved by an antenna mounting plate. Yep. But you're not going to say why? Lady. Jess. Dang it, I forgot why. It was something to do with I think a separator motor fired, or it was a separator or a parachute motor. I forget. Hey, Hellbore, 97 months. Thank you very much. "32. Incorrect vector data uploaded to shuttle's flight system, leading to the orbiter performing several rolls before it could be corrected." Ablative insulating material from the starboard solid rocket booster nose cap had hit the orbiter about 85 seconds into flight. Yeah, okay. I know about 27. 27 almost. Yeah, it was close. That thing almost didn't make it. But it did, so we're good. What's abnormally high tile damage? I don't understand. Anyway, SDS-91, chamber pressure sensor in one of the SSMEs failed. If it had occurred later in the flight, RTLS would have been triggered. What? RTLS later in the flight? Are we? How does that work? I'm going to have to go read about that one. Anyway, SDS-93. During main engine ignition, a golden pin used to plug an oxidizer post came loose and was ejected into the chamber wall of the right side SSME, causing a leak above the main combustion chamber. 5 seconds after liftoff, an electrical short caused shutdown of the center engine's primary controller, and the backup controller was left for the backup controller for the left SSME. 3 was shut down early, but it didn't affect mission orbit drastically. It's just good redundant engineering, man. Hey, Adam, what's going on? 68 months, thank you. Yeah, it had to have been earlier. Yep. RTLS is not a thing with the shuttle. That's death. Yeah, that's a good way of saying die. Yeah. So that I would call that one, that one's not good. We're proving why redundancy is needed. Well, Tavern Long, here's the thing. Like, let me put it to you like this. It's really easy to say, well, that failed. We should make it redundant. Now, it takes a really good engineer to say, well, that part failed. This thing failed. Should we try to go fix this problem, or should we just add a second one for redundancy? Because it's always a trade-off with aerospace engineering. You want to put 3 hydraulic power units in there for redundancy. Well, what's your empirical data for putting 3 of those there, right? What's the purpose? Why would you do that? That's adding so much extra mass to it. Why not 2? Why not 3? This just showed me that a lot of these near misses are just telling me that the guys who designed the space shuttle really did their homework. They really did their homework. That's some damn good systems engineering here. You know, the engines, the shuttle is the shuttle could just take one of their primary engine controllers, just blowing up, and it's all right, no problem. Second one took over. It's fine. So, it takes a good engineer to know when to add redundancy into a design and when not to, right? I don't even get it right all the time. Like, look at the grain silos. Grain silos and workers is a pretty damn good example. Right? It's really easy to just say, oh, put another one on there. Add another engine. Just one more lane, bro. Just one more engine, bro. Just one more booster, bro. Please, bro. It takes a really good engineer to know when not to do that. And that, once again, this just tells me that the people that made this thing really knew what they were doing. Like, really knew what they were doing. Like, the shuttle is ridiculous. Look at all this stuff. Are you going to be on NSF Live? Yeah, of course, Journey. Yeah, I'm going. Yeah, I'll be on again this week. Yeah. I needed last week off because Drummer was here. Agreed. Redundancy is only part of the total package. Yep. Also shows redundancy does not always solve problems. So Katra, if redundancy isn't solving your problem, fix the damn part, right? Like, it's not that simple of a workflow. It's very contextual because engineering is contextual. It's contextual. It depends. If you have a flat tire on an off-road vehicle, and if you have a flat tire on a race car, do they both get flat tires for the same reason? Nope. But they both have wheels, right? Like, it's all about what you're trying to do. That's super important to understand. And once again, this just tells me, like, how did they do this? It's still, like, reading through, and this is a pretty good list by Jess here. I don't know this person, but seems cool. This just, how did you know? Like, what's crazy to me is that this was the shuttle was the first attempt at a reusable vehicle. The first attempt. The shuttle was the first thing that was ever flown to space twice. Reused, you know what I mean? Even if Columbia was refurbished. STS-2, that was the first time we flew anything to space 2 times in a row. None of the Apollo capsules were reused. One Gemini capsule previously was reused, but the second flight had it was a Gemini capsule, but the second flight had nobody on it. Or the first flight had nobody on it. They launched it uncrewed, and then they brought it back and put people on it. So I guess let me amend that statement a little bit. Nobody had ever reused anything before with people on it both times, right? The only thing after the space shuttles to be reused was a Dragon capsule. And then Starliner in May, which is good. We're just now adding more to that list. But that was a first attempt. The shuttle was a first attempt. Are you kidding me? How did you do that? How did they make that? That's ridiculous. Considering the thing was designed entirely on drawing boards. Like, there's no computer here. Ain't no CAD here. Shuttle was designed in the early 70s. Wasn't the X-15 the first craft to go to space twice with people on it? Yeah, that's Denny over in the YouTube chat. Yeah, I'm more talking about orbital capable stuff, Denny, but yeah, technically, yeah, sure. Like, how did you know where to put redundancy and where not to put redundancy? How did you know? It's ridiculous to me. Like, there's all these systems on board that compensated for all these freaking problems, right? They compensated for all these problems. And the only thing that they really let slip through the cracks was foam insulation coming off and hitting the thermal protection system. Like, the SRB insulation exploded off and took a tile off the shuttle, and it still made it. That's I'm not saying that, just because you have 30,000 tiles doesn't mean you're 30,000 times redundant there. But also, the fact that they caught most of this stuff. They knew where the thing could fail. They knew what, they knew to put the HPUs or the APUs in triple redundancy. And they knew to put the fuel cells in triple redundancy. The fact that they knew to do that, and they knew where to add redundancy and they knew where not to add redundancy is ridiculous to me. Like, okay, what would be an example of not adding redundancy? Shuttle has no jet engines. It glides down to the runway. They wanted to put jet engines on it, and then they realized, why the hell do we need these? Look, man, you're not landing it on the runway the first time, right? You did something. You got other things to worry about than having jet engines, right? It's they knew where and when to add redundant. Like it's wild to me, dude. I still can't believe it. Like I'm still learning new things about this, and the shuttle hasn't flown in 10 plus years. It's crazy. I wonder if the foam coming off was affected at all by not painting the tank. Alex, I actually asked a guy that works on spray-on foam insulation for SLS that exact question. He said it wouldn't make a difference. It wouldn't have made a difference. All right, Dettau, see ya. How many other rockets were crewed the first flight? Never been done before, fifth. Never will be done again. No one will ever do that. Ever again. Keep a stiff upper lip about your slide rule and cadmium-plated... cadmium-plated plated washer. Yeah. Last time I saw you, dude, was in Pima in like 2019. Damn, Rudy. It's a long time, dude. YouTube chat's actually going off over there. What's up, guys? It's usually dead. I'm sitting over there watching it, you know, up until you guys started talking. The last comment was like 3 hours ago. It wasn't, but yeah. Would the jets have even allowed for a go around or just increased cross range? You would need... Yeah, MotoKid, it probably would just be for cross range. Yeah, probably would just be for cross range. But yeah, can you imagine how much the shuttle would have sucked carrying all that jet fuel up into space with 2 jet engines where the ohms pods? Frick that. Frick that. Like they knew where and when to add redundancy. I don't know how the hell they did that. How did you have the foresight to build that thing? You might want this. Can you use a link shortener next time? Anyway, moving on. Don't forget to like and subscribe. Greg, I'm not doing that. But I will hit the bell for fun here. There you go. I don't post YouTube videos.
Discovery,
yet.
go at throttle up.
Maggie, 85 months. Thank you. STS-95 drag chute door came loose during launch and impacted center main engine. Ugh. Yeah, well, they added the parachute because they added the chutes because of the brakes. Up here, there was a thing about brakes. Anyway. That was 95. 112. SRB hold down charges didn't fire. Clamps were ripped off by the SRBs during liftoff. Yeah. That was actually a planned redundancy. Tres comas. Yeah, Rudy. I got you. I have your VOD from the 2020 New Year's Eve. Managed to get on a GTA race with you. You have the 2020 VOD? Oh God. I sounded so tired. Yeah, Rudy, it was something. Yo, Greg, what's up, man? You did the eclipse. That's awesome, dude. That's awesome. All right. Anyway, STS-114. Yeah, they knew that would happen. The SRB, okay, so they knew that was engineered into the design, believe it or not, because you do not want one SRB separating and the other one not. The SRBs were designed to rip the frangible nut off the pad if one didn't fire. And even then, the igniters for the frangible nuts are in double redundancy. Yeah, there's two igniters. Denny, the Eclipse was about the coolest thing I've ever seen in your entire life. It was pretty sweet, man. It was pretty sweet. But anyway, yeah, that was designed to do that because you don't want one SRB separating and the other one being held down, because that, I mean, shuttle going sideways seems kind of cool, but you want it to go up. The only reason why the shuttle is bolted down with the SRBs is because of the thwang maneuver. So when the 3 main engines ignite, and so this is the external tank, this is the shuttle engines, right? in the shuttle. When the 3 main engines ignite, the whole stack rocks back and forth before SRB ignition, right? That's why it's bolted to the pad. It's bolted to the pad to make sure it doesn't slip off the pad when those things fire. When the SRBs go, they're designed to rip themselves off the pad. That was built into it. I've read about that. I saw my name mentioned. Yeah, drummer posts the YouTube videos. Yeah, see, Tessa, you crap posted and you woke him up. Why would you do that? Why would you do that? Kid's trying to sleep. Now how do you feel? Redundancy on the ground doesn't cost fuel. Well said, Broken. Very happy to see you still going. You helped me get into STEM. And now I just started in uni this year for Aero. Oh, really? Which you're at Embry Riddle. Which one? I'm gonna go ahead and guess the one in Arizona because of Pima. Yeah. Good. Annoying drummer is becoming a hobby. All right, Rudy. That's awesome. SLS does the same thing too, if you remember right. SLS does a twang maneuver, T-Man? No, it does not. SLS is not bolted to the pad. Fun fact. It's just sitting on it because gravity. I'm shocked someone other than you broke Rule 12. And man, you should take that personally. People encroaching on your territory, man. Just saying. You've been playing Minecraft all day, got out of bed at 10 a.m., gonna head to bed soon. You've been playing Minecraft. After what we talked about, you playing Minecraft all day, dude? Okay. Did Buran do a twang maneuver due to the off-center center of gravity? No. Rudy, Buran just slewed off the pad because the RD0120s would gimbal to compensate. So like if you look at a cross-section of the Energia stack, the 4 boosters that are on the Energia core stage are actually offset. They're offset opposite the shuttle. So like instead of being like right here, they're actually over here somewhere. And the shuttle is right here. And they would compensate. So Buran actually slid the opposite way off of the pad. The shuttle has the 3 main engines here and the SRBs here. And when it it twanged, and when it lifted off, it went that way. So Buran Energia actually does the opposite of that during liftoff. It kind of slews towards the orbiter instead of away. But it wouldn't twang because of the gimbal on the RD0120s. Yeah, they could really, really move. Good question. 1 week with you and now drummer's life is ruined. You had the itch to play it. All right, whatever. STS-114, foam strike. This was the flight immediately after the loss of Columbia. Yeah. Yep. It's really easy to get 2 shuttles confused. G-Man, what are you talking about? I don't know. Whatever. Here's an interesting thought on shuttle air-breathing engines, though. The placement of those engines would have improved lift over the wings under thrust in the same way prop wash does. Yeah, but I'll take payload mass. Thank you very much. Anyway, STS-116, STS-125 SRB debris hit the underbelly of the orbiter during separation. This list was done in numerical order to preserve my sanity. Thanks for reading. Yeah, Forge, it's an interesting list. I mean, once again, that's not a lot of, like, I would say that some of those aren't even near misses. Most of those were built into the design on purpose. You know, which is kind of crazy to me. I'd say the worst ones out of those are probably 93, STS 93 with the oxidizer pin, and STS 27. But that just goes to show you that the shuttle was really supposed to fly a lot.
Discovery, go at
I
throttle
really,
up.
hey, all systems 78-month resub. Thank you. I really wish that they had ended up flying it once a week. I really wish. That would have been amazing. I will say it once, I'll say it again. You fly it once a week. Most of those problems get fixed by the late 80s. And some of them probably don't even happen. But hey, what are you going to do?
Discovery, go at throttle up.
Inverter, 78-month resub. What about 51F? Bad sensor. It's a bad sensor. Yeah, that's what caused the abort to orbit. The engine was fine. Fun fact. Would have been helpful if it was an advanced ran and fly without crew.
Discovery, go at throttle up.
King, I would say if the shuttle should have had a way more robust testing regime, to be honest with you. I think that it would have been fine flying with people on board once a week, but you would need a healthier and robust testing regime. They would need to put that engine on the test stand and test fire it every day. How many hours of testing do jet engines have before they ever put the thing on an airplane? I don't know why they thought, for whatever reason, that rocket engines would be any different. Especially with something that's supposed to work like an airplane. Just putting it out there. Den, 9-month resub. Thank you very much. Would launch cadence like that require a few more orbiters? No. No, man, not at all. Orbiters can be refurbished in a month. Yeah, 1 month downtime. Yep. That's why they built 4 of them. Shuttle was supposed to ramp up to 48 launches per year in 1987. Yeah, that's what it was supposed to do. That was just the baseline. Engines were supposed to be good for 55 missions. Look, I'll say this once, I'll say it again. You don't design an engine to work 55 times without refurbishment and then miss the mark so much that you have to take it apart every time. That is a programmatic management problem. That's not an engineering problem. And that's what plagued the shuttle program. Yeah, you don't miss the mark. Aerojet Rocketdyne does not miss the mark like that. No, no, not a chance. You know, that's not how that's not how engineering is done. Anyway. So Rudy, what are you saying over in the YouTube chat? Professor loaded a shuttle MSS in the sim a couple months ago. The stick was so heavy and you can easily lose all your airspeed with one mistake. Must have been hard for the pilots to land it. Lots of training. Yeah, exactly, Aqualex. The test program wouldn't have been done until we were hitting the cadence. Yeah, dude, all the developmental engineers were gone by Flight 5. Who made that decision? Yeah, like, what the frick? For real, what the frick? Yeah, unbelievable. In fact, they mentioned that in one of those training videos, one of the shuttle videos that I used to show when I took breaks on the stream during the pandemic. Yeah, one of them is like, oh, we've reduced the amount of people in mission control by 50%. Yeah, I might be extrapolating a little too far, but that means you got rid of all the developmental flight engineers. Oh, that's good. You did what? Could you show that guy getting pumped up after landing? It's not that guy. That's John Young, man. Don't ever you not refer to him as that guy. That's John Young. That is the closest we've gotten to Jebediah Kerman in real life. All right, man. It's a good video though, but it's from one of those videos, Blackness. But yeah, maybe we'll show it later. He is the guy. He's the guy. right? Not that guy. He's the guy. Him and Tex Johnson. Tex Johnson is definitely the guy as well. I was bummed when John Young passed away, man. That really pissed me off. I was not happy. I was not happy. That was a bad day. John Young is involved. We need a corned beef sandwich. You're damn right we do. What about corned beef concealer? What are you talking about? A pocket? Dude, first of all, homeboy put a sandwich in his pocket. All right? You know how much of a legend you have to be to just be like, let's put this in here and save it for later. Like, you know how much of a bamf you need to be like that? I've been here long enough. I should have known. That's all good, man. It's all good. It's all good. I'm sure it was wrapped, but also in your pocket. All right. You reckon Gus Grissom would have been the first guy on the moon had Apollo 1 not gone awry? Yes. Absolutely. Him and Ed White would have been the first two. Yeah, that actually happened. John Young snuck a corned beef sandwich on Gemini 3. I think it was Gemini 3. Yeah. He was up there with Gus Grissom, and he snuck a sandwich up there. And NASA was like, John, what are you doing? He's like, yep, I'm just going to eat some of my sandwich now. Just took them with me. My personal effects. Personal effects for like bringing pictures of your family, sir. Why did you bring a sandwich? Because I was hungry. John, don't eat the sandwich. John, don't eat it. I might eat the sandwich. John, do not eat the sandwich over. That actually happened. Yeah, that happened. Oh yeah, NASA got pissed. It's really funny. He's like, well, ain't nothing you can do about that from up here now, can you? Oh yeah, that actually happened. Yeah, it's pretty funny. Yeah, he didn't like it, but he brought his own sandwich. NASA was worried about crumbs shorting out the electrical system. They didn't, so it's fine. Best part about that is because it's NASA, it's public record. Yep. So Rudy over in the YouTube chat. I'll give a salute to Michael J. Smith and Dick Scobie. They managed to save Challenger through re-entry with one wing. Rest in peace. Smith and Scobie were Challenger, not Columbia, dude. Yeah. You're looking for Husband and McCool on Columbia. Yeah, they flew it. Yeah, they flew it with one wing. It was the Aero Forces that got it, which sucks. But what are you gonna do? Hey, Taxavator, what's going on? Didn't he say it wasn't that good either? Yeah, sounds like that. John Young is amazing. That guy was the best. He was, you know, you want to know what kind of guy John Young was? And I've said this on stream before, but I'll say it again. After he retired from NASA, at some point, they named a road in Central Florida after him. And, they were dedicating the road, and he was there. It's John Young Parkway in Orlando, if you're wondering. Yeah, it's named after an astronaut. I know, right? And they brought him there, and they said, we named this road after you. How do you feel? You know what he said? Why are you naming roads after me? I ain't dead yet. Thank you, though. That should tell you everything you need to know about that guy. Yep. My hero. That's awesome. It's so funny. Why are you naming that after me? I ain't dead. Yes. Awesome. Oh, that's pretty funny, man. He's also known for such banger quotes as, any person that straps themselves to the largest hydrogen and oxygen thermobaric bomb doesn't realize that they're close to death, doesn't understand the situation. I'm paraphrasing. It was something like that. Yeah. Oh, wait, no, what was it? What did he say? He said, anybody that straps themselves to the largest hydrogen and oxygen rocket ever made, knowing that they're going to light the bottom of it on fire, doesn't fully understand the situation. If it's my road, I can't get a speeding ticket. Yeah, there you go. Anyway, let's move on with space news. John Young's the man. He's the man. First guy to ever fly the space shuttle. First guy to ever fly the space shuttle twice. And apparently the APU's caught on fire. It didn't bother him. Yeah. All right. Anyway, let's see. So this is coming from Astranus Space Technologies. They're working on, this is another satellite internet constellation here. What's up? What's going on? Let's see. Introducing Astranus Omega, pound for pound, the most powerful satellite in geostationary orbit. 50 plus gigabits per second, Ka and X bands with the ability to launch 12 Omegas on a single medium class rocket. Watch.
Higher orbits are what first inspired humanity to reach for the stars. But in recent years, they've been overlooked. At Astranus, we believe the future lies
I like them too,
in
Fifth
higher
Force.
orbits. And today, we're taking a major step towards a faster, smaller, and more powerful GEO. Introducing Astranus Omega. Omega is 5 times as powerful as Gen 1. It's faster to build, and it's still a micro-GEO. We've proven the Astranus software-defined radio on orbit, and now we're going even further. Omega will be pound for pound the most powerful satellite in GEO.
Interesting.
With 50 gigabits of dynamic capacity that can be reallocated on orbit, Omega shows that flexibility and performance are both possible. We can launch up to 12 Omegas on a medium-class rocket, and with over 70% of Omega built in-house, we have the speed we need to build 24 satellites per year to surpass the rest of the GEO industry combined. Rather than building bigger systems slower, we build small systems faster and more powerful than ever before. The future is in higher orbits, and Astranus is building both. We're bringing about the new era of proliferated GEO with Astranus Omega.
Interesting. Interesting. Yeah, Tesla 50 is not that much, but there's a lot. This is a bigger constellation. See what I'm talking about? Each one of those is 50. That's 12 at 50. That's and yeah, a medium class rocket. Gee, I wonder what rocket that is. Why isn't the fairing connected? What's that about? Why is the fairing bent? What? Why is it off-centered? That's weird.
We can launch up to 12 Omega.
It's easier to release if it's not already attached. All right. All right. I wonder what the FAA might think about GEO constellations. Not their jurisdiction. That's much more the FCC. And by proxy, kind of the Space Force King. Makes sense to me. Now, we were talking about the shuttle here, but actually, I'll get to that in a second. It's interesting that Astranus is working on building a small sat GEO constellation. Generally, the trend with satellites, dudes, the trend that's been kind of a thing, thanks to SpaceX and Starlink, has been instead of gigantic geostationary communication satellites that have a shelf life up on orbit of about 10 to 15 years. The trend in the satellite launching market has gone from those big satellites down to 5-year life cycles. And instead of like having 10 satellites in a geostationary communications orbit, you have like 3,000 in a low Earth orbit, right? So the trend for satellite building has been make a smaller satellite and don't shoot it off as far. Starlink, Project Kuiper, right? OneWeb. You get the idea. So It's interesting that Astranis is looking at making a smaller GEO satellite. That's very interesting. That they're, everybody's kind of moving towards LEO and they're saying, no, let's stay up in GEO but build smaller satellites. It's an interesting business strategy. I mean, I'm wondering, it's an interesting strategy, Cotton. I'm wondering if it's going to pay off. No, I'm serious. I'm generally curious. My bad, FCC. Yeah, all good, all good. They have 11 satellites on contract over 5 years from various customers. Interesting. Smaller GeoSat buses. That's an interesting pivot, Phil. I'm actually kind of wondering how that's going to end up. Yeah, Rudy, that sounds right. But yeah, I mean, also Starlink satellites are a lot closer. Can Astranis satellites deorbit at end of life? No, they'll probably get put in a graveyard orbit up in GEO. They're just manufacturing small geosats. They aren't building their own constellation. They're not building a constellation. They are targeting small countries that want their own capability for internet or TV. I definitely saw them advertise that they can broadcast on the military bands, but yeah, for TV. But don't want to buy giant geosats. Interesting. That's weird. Yeah. Yeah, this is just GPS for hire. Yeah. Interesting that they're not building a constellation. They're just building a sat bus. Huh. And also marketing faster development to launch times versus big legacy geostation. Yeah, I got that part. Yep. Huh. They made a big point about showing ion drives, a huge amount in that video. I wonder if that plays into longer lifespans and allows for smaller satellites. Yeah, I'm not sure. Maybe. Rudy over there. So the small GeoSat will boost itself from geostationary transfer to geosynchronous and manage to hold station with onboard fuel, or is it a direct injection? With Falcon 9, Rudy, I would guess it's a geostationary transfer all day. Yeah, geo transfer. You could do direct to geo with Falcon Heavy, but yeah, I mean, I would say Falcon 9 on a geostationary transfer with a drone ship landing if I had to guess. And a peanut butter jelly with a baseball bat. Peanut butter jelly, peanut butter jelly, peanut butter jelly with the baseball bat. Sorry. I can't count how many commercial satellite buses you've seen in the past 6 months alone. Nearly every company, including SpaceX, is making a bus for Starshield, if I can remember. We don't talk about that here. Oh. Yeah, interesting. I mean, the lifespan thing is primarily onboard fuel, right? Yeah. So, Phil, their first satellite flew with Viasat 3 Americas into direct geo on Falcon Heavy. That's right.
Discovery,
yeah, they had that secondary payload. I remember. Devious. 48 months on a 45-month streak. Thank you. All right, Sun Temple. Have a good night. Have a good night. Anyway. I'm going to need to go fill up my water here in a second. So, check this out. Pivoting a little bit more. NASA History Office. On this day, in 1979, Enterprise rolled out of the VAB for fit and function checks to prepare for the first shuttle launch of Columbia. Yeah. Columbia, 2 years later. Here, let me just put it to you like this. It didn't take them 2 years to do fit and function checks. The tiles fell off. Yeah. Are those loaded SRBs? No. Probably not. Starship direct injection. Let's go. That is actually, you know what, Bill? I'm not sure. They might be. It's got. Oh no. That's not. That is not a flight external tank. At least not in this configuration. It's missing a bunch of pieces. You have no autogenous pressurization lines. Yeah, that's. I was gonna say this might be the STS-1 stack, but if it is, yeah, that would have to be all taken apart. You're missing a ton of pieces. Enterprise looks so different to the later orbiters. That's because it's painted differently. Hellbore. It's the same exact shape. Yeah, in fact, Columbia is based off of Enterprise. Actually, they were manufactured around the same time. Enterprise was painted where they thought the tiles needed to be, and Columbia was where the tiles actually needed to be. Yep. I have that exact picture hanging up on your wall. Oh, that's cool. What do we got back here? Oh, bird. What do we got over there? Shuttle. Furred fire truck. All right, that's cool. That's cool. Yeah, that's pretty neat. Interesting how the color changes the profile so much. Yeah, right? Right? Yeah, I was staring at Enterprise 2 days ago. Or 3 days ago. Yeah, it's just painted different. Did you hear the news, Jackson? Yep, we'll cover that in a second. I have it teed up. Rockwell International was the contractor for the orbiter hammer. Yep. Rockwell was North American Aerospace. Previously, they made the Apollo Command Service Module and the P-51 Mustang, amongst other things. Are you sure there's a line on there? Do I look like the kind of melon farmer that would be unsure about this? How dare you? How dare you? How dare you? You have stolen my shuttle's dreams. How dare you? Anyway, I'm not mad. And the B1. Yeah. B1. Yeah, also good. What, Tessa? Oh, yeah, sure. I don't know what that means. We have a Rockwell building on campus, though it has a Boeing logo on on it. Wait, this means Boeing built the shuttle. No, Rudy. No. Rockwell engineered the shuttle. Rockwell designed the shuttle. Boeing bought Rockwell, and Boeing operated the shuttle. Boeing wishes it could make a spacecraft like that. You wish you could make a spacecraft like that. Freaking wish. Hey, do you have your license? Do you drive around? Does that mean you can build a car? Hell no. Operating a car and building one is two different things. And before you say, well, no, even if Ford handed you one of their car factories right now and said, here, run this for me, would you know what you're doing? Absolutely not. See? Yeah, boom, roasted. Hammer Nails, I just put some money in ARC, space exploration and innovation. Hoping this takes off. Oh, have fun with that. Tessa, I said like the shuttle. I think Starliner will work just fine. All right. Next bit of news. It's their MO. McDonnell Douglas likes buying into accolades. Yeah. Water. That's a good point. Here, read this tweet. I'll be right back. Look at this graph. Ugh. Water. All right, so this is coming from Marsha Smith, and guess what? This is Starship news. So you know what? Maybe we should actually like put that last. Here. Hey, space. Want to go to space? Well, look at this. We have Administrator Senator Nelson here to deliver a message for everyone to hear. Administrator, take it away.
Today, President Biden announced a historic agreement. Japan will develop, for NASA's use, a pressurized rover to rove with our astronauts on the lunar surface. It's a mobile habitat. It's a lunar lab, a lunar home, and a lunar explorer. It's a place where astronauts can live, work, and navigate the lunar surface, leading to magnificent discoveries for all of us. What better representation of the power of partnership than this vehicle? It's going to lead us to cover ground we've never covered before because they'll be out and can stay for several days on the surface. That means cover it literally, scientifically, and diplomatically. And what better representation of the promise of partnership than President Biden's announcement today that America will no longer walk on the moon alone. In the future of the Artemis campaign, 2 Japanese astronauts will join Americans on the lunar surface. We are going, and we're going with Japan. Our partnership with Japan goes back decades. It touches every corner of our work in space and in the skies, in science and technology, to study our fragile Earth and to help protect it. And so today's agreement is about so much more than just this vehicle. It's about humanity's shared dream in the cosmos. Space teaches us many lessons. One of them is diplomacy is good for discovery, and discovery is good for diplomacy. When great nations work together, we extend our reach into the stars. And that's what today is all about. A giant leap forward for all of humanity through the cosmic partnership of the United States and Japan.
Toyota-san. No, Toyota-sama. Toyota-sama. Well, at least we know it's not going to break. That's pretty cool. And it has deployable solar panels. Yeah, see, this could just be a Hilux with an extra set of wheels, and I'd be good. We'd be good to go. Is that a cable winch? Oh, God, I hope so. Oh, that would be awesome. What's going on with the wheels? Ardwington, on the moon. So, moon dirt, it's called lunar regolith. It's the dirt. It's the dirt. That's the gray stuff. That's we can see it. We can see the dirt. The dirt is super, super fine. We knew that from we know that from going to the moon 6 times. 6 times. Should have been 7, but some idiot dropped the oxygen tank. Anyway, I digress. We know from going to the moon, the lunar regolith sucks. It's like talcum powder, or baby powder. It's really, really annoying. It gets everywhere. It's fine, not rough, and it does get everywhere. So basically, a regular tire could work, but you need a finer tread to go through the finer soil. Yeah, that's really what it is. I mean, different tire for different terrain, dude. Good question, though. Who's delivering it? That's Starship's got to be putting that down on the moon. Why does he talk so slowly? He talks really slowly because he has been around the block a couple of times. Ooh, battery design. I mean, yeah, it looks pretty rad, man. What the heck? You want that front? What? Oh, jeez. Solid tire or the mesh? That looks like mesh to me, dudes. It is a cable winch. Sweet. Yeah, statically charged, right? Yep. Lunar regolith answers the question of if something that's soft and fluffy can be sharp. The answer is yes. Where'd you link this? Oh, there are 3 different pictures. Yeah. Interesting. I like things that are fluffy. He almost sounds like Hank Hill. No, he does not. Those are 2 completely different accents. Yep. Dang old moon rover man, gonna drive around just gonna drive that dang moon rover down on the surface, man. Damn. Did I see all the pictures? You're damn right. I did. You remember Apollo 8? You remember that? That was a mission. And the proof is the proof is in the pudding. And I'm just dandy. I got a bowl of chocolate pudding down my underpants. Anyway, it looks like it's got removable batteries and deployable solar panels, which is actually super cool. And a winch. That's pretty neat. No, stop it. Sorry, my bad. We now go to live to Ollie Williams for the Lunar Weather Report. Ollie? Thanks, Ollie. He didn't have his radio on. Makes sense if you want the thing to stay there. Yep. Nah, Bill's all right. He's still kind of pissed me off with that whole pissed me off with that whole launch when it's safe. It's annoying. Anyway, what are they going to use with the winch? There's no trees on the moon to anchor to. Yep. Tessa, tell me you've never been four-wheeling without telling me you've never been four-wheeling. You can loop a rock. That's fine. You can loop rocks. In fact, if I'm stuck on the trail, I mean, I've really never gone four-wheeling myself, but I watch way too many people do that. If you're up on the trail, you can loop a ratchet strap around a boulder and then just loop the winch around the ratchet strap, pull yourself right out. In fact, I'd rather winch to a rock. It's not a boulder, it's a rock. Oh, Jackal, that's neat. Anyway. Okay. Anyway. Artificial trees will be planted. All right. The man in the moon will hold the winch for you. Yes. So Toyota made an indestructible for-Earth vehicle called the Hilux. It's now making one for the moon. Well, that's what the contract is for, and the contract is also for 2 JAXA astronauts to land down on the moon with us. So, hey, that's cool. I mean, if you're going to choose to go into space with any nation, I'd choose Japan, man. Like, I'd be like, hey, yo, can you guys, like, make a mech suit or something? You're good at that. I've seen it. I've seen that documentary once. I've seen that documentary once. Please make a mech suit. I already covered ExoMars, Creeper. How can you have any pudding if you don't eat your meat? Full video from Toy Letter. Yeah, Hiluxes. Hiluxes are a good time, dude. Yeah, Virtual. I mean, Virtual, you don't need to tell me. I like trucks. I'm a truck guy. I'd celebrate the entire catalog of trucks. Yep. I do. I am a pickup truck fan. For my money, it doesn't get any better with an 8-foot box. I celebrate the entire genre of vehicle. Yeah. I'm a Michael Bolton fan. The unnecessarily big ones too. Arts, I don't have a problem with big trucks. I have a problem with people buying big trucks and modifying them to make them do all the stuff that they paid for the truck to do worse in the name of trying to make a truck look good. Trucks don't need to look good. It's a utility vehicle. It's not about looking good. I don't mind big trucks if you use them to do big jobs. My problem lies with somebody that's going to buy a big truck that can pull like 100,000 pounds and then put grocery bags in the back. Yeah. Okay. Yeah. That's my thing. What about monster trucks? Monster trucks are awesome. Monster trucks are awesome. Yeah, those are all right. Some assembly required. Yep. Well, it's their dream to do so. Hey, Burke, money doesn't buy you taste, okay? All right. But that's cool. That's good news. And that's actually super cool that Toyota's building the Rover. Yeah, it's always better to use off-the-shelf components when you can. You don't know. They could be hauling a ton of groceries. Sorry, I think some smoke just came out of my ear. No, whatever. You can modify your vehicle in any way you see fit, but that does not mean I won't give you crap for it. Yep. Anyway, Starship time? Starship time? All right, so a little bit of update for the Starship Flight 4 here. This is from Marcia Smith at Space Policy Online. At a media briefing at the Space Symposium, FAA AST's Kevin Coleman says the next Starship launch has to both clear the mishap investigation and get license modification because they're planning to do some different things. Up to SpaceX to say what those different things are. Could be done by May, but no commitment from the FAA just yet. Okay, looks like our estimate on a Starship Flight 4 for May seems to be pretty much on the money. Dude! What's up, Armory? How are you? Are we counting bro, correct me if I'm wrong, but CSA was landing with us on the moon in the first runs. Jeremy Hansen is a Canadian Space Agency astronaut that's flying on Artemis 2, Rudy. Artemis 2 isn't landing on the moon. It'll fly by the moon. It's kind of like Apollo 7 and Apollo 8 rolled into one mission. More details below. Below me. Below me or below the tweet? Oh, below the tweet. Okay, cool. Coleman says they'll soon be out with a reentry policy statement reflecting lessons learned from the Varda experience where the FAA allowed them to launch even though they still didn't have their reentry license. The FAA denied their first application. FAA doesn't want to do that again. Interesting. Varda had a prototype reentry vehicle. They launched it without having a license to reenter, and the license to reenter the payload was granted during while the payload was on orbit, just in case anybody wanted context. Forge says, Backroad Chatter says that SpaceX is going for a highly elliptical suborbital launch and reignition for splashdown. Forge, okay, I'm just gonna go outright and say it, and I saw next to nobody say this. The reentry trajectory that Starship took for IFT-3 would have destroyed anything. Yeah. If the space shuttle flew on a trajectory like that, it would have been Space Shuttle Int. Same with any capsule. That Starship entry trajectory was insane. That was an insanely steep trajectory. Yeah, that's ridiculous. Most re-entry trajectories do not have a negative perigee. Not even close. Most re-entry trajectories have the perigee somewhere halfway in between the Kármán line and the ground. What does that mean? Most spacecraft with people aboard enter on a much shallower trajectory than Starship did. Starship did a belly flop into the atmosphere, quite literally, a belly flop. Like, yeah, not good. So, like, think about it like if you were throwing rocks into a lake or something, right? Most things that have people aboard that re-enter would be like throwing a rock that skips across, skips off the water a couple of times and then falls in, right? That's how, like, the shuttle came in. Shuttle came in, spending most of its time in the upper atmosphere, just chilling up there and slowing down, and then fell like a brick out of the atmosphere, right? That's Apollo skipped off the atmosphere, like that skipping rock. What Starship did was the equivalent of taking a boulder and dropping it in a lake. Just, boom. Anybody go camping? You know that noise. If you take a big boulder, you drop it in a lake, it makes the boom, boom, right? That noise. That's what Starship did. Dude, even if the tiles even if the tiles hadn't fallen off, there's no way that thing would have made it through reentry. I'm just saying it right now. That if it did make it through that reentry, that would have been insane. Nothing would have been able to do that. Yeah. Yep. They got the booster back to the pad in 3 weeks. Static fired and then destacked it, all in the span of 3 days. And in total, it looks like it might be launched 2 months after Flight 3. That's a 50% difference between 2 and 3. Yep. Yeah, Contra, I think Flight 4 will fly on the same exact trajectory. KSB terms now. Not suborbital. Aero braking, dead crew. Yeah. Starship was more like an ICBM. It flew on an IRBM trajectory, Contra, yeah. I don't know why people why more people aren't saying this. That reentry was insanely steep. Nothing would have survived that. Nothing that we have. But then again, nothing like Starship has existed in the past. So if you tried to fly the shuttle on that reentry, that would not end well. You, at the very least, would have damaged it during reentry, and maybe it would have made it. Capsule, you would have exhausted your ablator real quick. But then again, what the hell do I know? I don't know. I'm just a Twitch streamer. According to McDowell, the perigee was 50-kilometer pre-flight. 50-kilometer perigee with Starship? How is that possible? It came down in the Indian Ocean. How could you be orbital and re-enter over the Indian Ocean 20 minutes after insertion? That makes no sense. I mean, I'm not saying Jonathan McDowell was wrong, but also, I don't think so, Bill. I'm not sure, though. Yeah, but Aqualux, this thing was on an entry trajectory to come down in the Indian Ocean at engine cutoff. They said that the deorbit burn would not affect the reentry trajectory. That means they would have done the burn well past AP. That burn that they didn't do. Hey, D-Claus, what's up? Which is interesting. What's the G-loading on the ship with said trajectory? Death. Not great, Bob. Not great, Bob. SpaceX tweet. We have pictures of the payload. SpaceX tweet. Targeting Thursday, April 11th for Falcon 9 to launch SF-62 to low Earth orbit from Pad 4 East in California. The U.S. Space Force is launching the Weather System Follow-On Microwave Space Vehicle. Or WSVMASV. The first of two satellites that would create a more hybrid space-based environmental monitoring architecture. The payload was encapsulated into our flight-proven fairings last week. I forgot to texture it. Yeah, exactly, Kevin. They said the burn was going to happen when the Delta V would have had very little impact on trajectory, which means that thing was super suborbital. I'm not sure how it could have a 50-kilometer perigee unless it was a 50-kilometer perigee at insertion and it aero braked the rest of the way, which makes sense. But that means if it's aero braking as it's going across the Atlantic Ocean, right? That means the reentry trajectory is going to get extremely steep, extremely fast, right? Because it's going to slow down and that's my guess as to what happened. But still, to come down in the Indian Ocean after an orbital insertion at a KSC at like a 45-degree inclined orbit, not out of KSC, excuse me, out of Boca Chica, and it probably wouldn't have been a 45-degree inclined orbit, probably would have been like 20 degrees, but doesn't matter. Yeah, there's not much that would have survived that period. Yeah, I'm just saying. I think the 50-kilometer perigee was for flight 1 and 2 when it was supposed to go to Hawaii. Yeah, Denny, maybe. That was over in the YouTube chat. You might be right, dude. Yeah, that could be correct. But I'm pretty dang sure that not much would have survived that type of entry. That's the type of entry trajectory that the external tank would fly on from the space shuttle. A re-entry trajectory that was purposefully designed to completely disintegrate the vehicle. Now, don't get me wrong, the external tank never had any thermal protection systems on it except for the one to insulate your propellants, the orange foam, right? But also, it was the Centaur that delivered OFT2 and OFT1 for what it's worth, also flew on a trajectory very similar to that, and those are that's a disposal trajectory. That's not a come back down and land trajectory. Let me put it to you like that. Wasn't altitude for most of the journey too high for aero braking? Yeah, Laz, I'm wondering about that 50-kilometer insertion, but 50-kilometer perigee insertion. But yeah, who knows? Master Chief and Noble 6 could have. Okay. It has an umbrella. What's that? Is this Ball Aerospace? Is this the same? What the hell? Is that the same ball that makes jars? Ball. Yeah, but it's now a BAE Systems company. Ugh. Yes, it is. They also sponsor my arena. They don't make jars anymore. They don't make them like they used to, boy. I tell you what. All right. Oh, dang it, Bobby. Oh, boy. Oh, they make aluminum cups. Oh. Anyway. Sorry. Twitter had my attention there for a second, and I felt myself losing brain cells, so I stopped. This is a good one. Nice. Mm, that's bait. That's pretty good, man. That's pretty funny. SpaceX made a rocket with a reusable first stage that sends a capsule to Leo. Great, so what? NASA figured that out in 2009. Nope. That's bait. Not only is that funny, that's the guy that designed the Merlin engine for Falcon 9. Nope. That's, you know what? There's a lot of weird things in this timeline. There's a lot of weird things, but seeing ex-SpaceX and current SpaceX employees crap post on Twitter is, you know what? That's a part of this timeline I'm here for. Yeah, that's a part of this timeline I'm here for. That's great. Please keep doing that. Yeah, that's good. Yeah, you should keep doing that. Yeah, indeed, Yuri. The world changed after that. This unique coffee cup was designed to never spill in space, huh? Nicole, what are you doing? Oh. That's a really good design. That was the last link for space news. Who linked this nonsense again? Oh wait, there was one more. What is this? No. Yeah. No, it's a nice cup armor. You know what I'm saying? But it's trying to keep it classy. It uses the capillary effect. Oh, yeah. Here, look at this. Teague, I don't have anything on the horizon. I'll tell you as soon as I hear something, I'll let you know. Imagine a 747 is sitting on a conveyor belt, as wide and as long as a runway. The conveyor belt is designed to exactly match the speed of the wheels, moving in the opposite direction. Can the plane take off? well, Forge, that's broken. Nope. No. Yes. No. No. Yes. I don't. It's a point, so no. That's the best answer. That's the best answer, Phil. That's the best answer. All right. Yep. On my way to St. Ives, I met a man with 7 wives. Every wife had 7 kids. Every kid's had 7 cats, getting cat sex and wives. How many people were going to St. Ives? Yep. 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 No, that yeah. You guys can argue about that in the chat. I'm not even opening a discussion with that thing. No, we ain't doing that. Not willingly. The answer is 1, but I didn't say Simon's. Yeah, Wayne, that makes sense. Yep. Wings need wind. Yeah, not this again. Yeah, that's right, Fitforce. The comments on this tweet were interesting. Yep. Guys, the plane can't take off. The only thing would be the rolling resistance on the bearings and the wheels. If there's rolling resistance on the bearings and the wheels, the 747 could theoretically get a forward airspeed. And if it gets a forward airspeed enough to generate enough lift to take off, then it can take off. But for the most part, no. It's all about airspeed moving over the wings. It's local airspeed. It would overspeed the tires, though. Yes, that's correct. You would probably fry a wheel bearing doing that because all the grease would burn off. A blade of grease. A blade of lubricants. Not a good idea. Not great, Bill. Not great. Something blow by. Something. Oh, also, Bill, real quick, I have a line on a 5.7 Hemi for the Coronet. You want to come down here and help me wrench? If I get the vehicle that I want to get the parts that I need, want to come down here? Want to come down here and wrench? Want to come down and wrench? We could do it on stream. Probably shouldn't have asked you this on stream, but hey, whatever. You're on the spot. Deal with it. My brother built one just like it for his boat. For this boat, very cool. Nice. Sounds sick. I hope I can get it. Yes for Boeing, no for everybody else. Yeah, we need to put a Hemi in that thing. Where's my invite, you butt? You don't live near me. You butt. Unless you want to drive up here, Sawyer. Your mic is a little low. I have to boost you to listen clearly. How's that? Better? Worse? Banana? 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 Hey, Reputa! Reputa to Buta! That actually should be a lot louder. Is it a lot louder? It should be. All right, cool. We're gonna turn that down a little bit and make sure that doesn't do that again. Okay. All right. Yeah, that's a good idea. Now, hold on. Let me balance the channels. Oh, your left ear loves this, doesn't it? Oh yeah. Yeah, look at that. We got the mixer working, bro. Life's the same. We're living in stereo. Bow, 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 bow. All right. All right, I'm stopping. Joke's on you. I listen in mono. Well, I hope you get better soon. We have finally reached EJSMR. Sorry. PTSD from the NASA teleconference. That tickles. Sorry. Rudy, what are you saying over there? What was your ITS clone in KSP? It had a crazy booster named Neptune. Neptune. Just checked the old hard drive and I found a ton of footage. Yeah, Neptune. Nice. How did you get the mixer to work correctly? Just push buttons until it started doing it? SpaceX Twitter. It's urgent. It's so urgent. Dun, 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 dun. Baby, it's urgent. Dun, 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 dun. Urgent, urgent, emergency. Right? Yeah. I have the power of the foreigner belt. No? With the power of the foreigner belt. You're hot-blooded. Go ahead and check it and see. Oh. Oh. Can we go back to the old setup? Hell no. Oh. Does that mixer have a center channel out? It's quieter when you're centered. No? Yours is no disgrace. Oh, good song. Ching, ching. That's a great song. Pulse jet. Why not build your own pulse jet in your nice shop? Because I'm building automobiles instead. What was the caption for this? Sorry. Shutdown of a Raptor vacuum engine in slow motion. The engine's nozzle is sized for use by Starship in the Earth's upper atmosphere in outer space. So operation at sea level and low chamber pressure results in flow separation, creating visible rings in the exhaust. Yeah. I want to put my face into it. Just want to motorboat it. Yep. See? Okay. Stuff is happening here. Do you want to know? Would you like to know more? It's orange. No, it's blue. It's blue. It's blue. Yeah, program it. Just turn it on. Yeah. No, I just kept hitting buttons until the mixer things worked. The stiffener ring is doing work. Indeed. Yeah. This would break things if that piece of chunk right there, that wasn't attached to it. Yeah, this would break things. So check this out. This is an engine shutdown that SpaceX posted for us here. So you can tell that the engine is throttling down in preparation for shut off here because the shock is moving closer to the nozzle. Now, what is this? Why is that a thing? What is that? What's going on here? So when you're testing engines down at sea level, even vacuum engines, now they can test Raptor vacuum. This thing is designed to work up there. It's not designed to work down here, but they can test it down here. The reason why is because Raptor is nuts. It has really ridiculously high chamber pressure, so you don't need to worry about that when you're down here. So when you're testing engines down here, you usually get what's called an underexpanded plume. Well, at least if you want the engine to work correctly, you're getting an underexpanded plume. So what does that mean? What does that mean? So look at the flames. The flames, the actual explosion coming out here that's going behind my melon right here. You see, if you look at the angle from the nozzle, right? Just kind of the angle that the nozzle's going, right? That's called an expansion ratio. That, it's usually a parabolic arc in some way, shape, or form, right? you see it's kind of going this direction, right? You see how the gases coming out of the rocket engine after they exit the nozzle kind of bow out a little bit. See that right there? They kind of go out, right? So why does it do that? Well, once again, that's called under expansion. Why does that happen? Well, basically, if you want your rocket engine to not explode and do that, you basically will make enough explosion in here to fill up the entire nozzle and then some. Think of it like volume almost, right? It's volume. You want the explosion to fill up the entire nozzle and then some. That's called plume under expansion. Okay. Now, if you notice, it bows out and then the flame immediately starts to converge. See, these lines are clearly going inward. What's going on there is that once again, the Raptor's generating enough explosion to fill up this nozzle, plume under expansion. Because your ambient pressure is at 1 bar, i.e. they're testing at sea level, the weight of all the gases in the atmosphere are pushing those flames in on each other. Right? Basically, you got a lot of flames right here. They're really hot, so when they come out of the nozzle, they expand like crazy, but the atmosphere pushes them back in, and the plume ends up collapsing in on itself and bouncing off of itself a couple of times. That creates what's called a shock. That's what this is. Specifically, that creates an oblique shock right there. That's what that's called. It's the gases collapsing in on each other. Now, you can see that the oblique shock in this footage is moving towards the nozzle. And if you watch as they throttle it down, because when you throttle the engine down in preparation to shut it off, you might get a brief period of overexpansion where you get flow separation inside of the nozzle. Basically, the explosion that the motor is generating isn't enough to fill the nozzle anymore. That's what you see happen here. Watch. As your shock moves closer to the nozzle, watch this flow. It stops bowing out and it just starts to converge. See what I'm talking about here? Shock the monkey. And when the explosion is not enough to fill the entire nozzle, right? And it starts to converge out, it starts to converge in before the nozzle exit, that can collapse your oblique shock. And it collapses the shock. That's what you're seeing right there. That turbulent flow is the result of not having, amongst other things, it's the result of not having a good, not getting good under expansion. And it causes cavitation inside of the nozzle. So here you kind of get this, see in this particular shot, you see there's lines that are forming on the inside of the nozzle. That's from cavitation. Those atmospheric gases are pushing in the nozzle and trying to collapse that flame as quickly as possible because, once again, you have the weight of the entire atmosphere above you. You can see the atmospheric gases are pushing themselves in and trying to collapse that plume. Right there is very dangerous for a rocket engine because you're changing a lot of things really fast. It's a very turbulent and violent, well, actually turbulent. You see the turbulence going on here. See that? That's not good for it. That's actually one of the most violent parts of a rocket engine's duty cycle, I guess. He said duty. Nice. Because cavitation inside of here can cause, well, vibrations, obviously. And look at the camera. The camera's like... And it can also cause non-uniform heating and non-uniform pressure on the inside of the nozzle. Having non-uniform pressure on the inside of the nozzle can cause it to collapse in on itself. Not good for it. That's not good. You don't want this thing imploding like that tanker car on the Mythbusters. Like, it could do it. We've seen it happen, right? That's part of the reason why this Raptor vacuum has that stiffener ring right there. That's there to make sure that doesn't happen. Look at all the extra bracing they have on that nozzle to make sure that this doesn't happen. So because they have the bracing on the nozzle, you can actually see a really, really, really nice shutdown here. Something is popping every time you pause the video. I hear nothing. Your words are cutting out. Your words are cutting out. I have no idea why that's doing that. to be honest with you. Oh, boy. It's the bass in the video. I don't hear any... Oh, it's the video itself, guys. It's the video, guys. It's not me. Yeah, it's the sound was recorded. You get a fragmented sound because, yeah, the microphone and stuff. Basically, it couldn't record all the sounds that this thing was doing all at once. But here, that should be good now. Happy? Yeah, there you go. Look, you can see the flow separation that's happening right there. See? Dude, this would crush this if they didn't have the bracing in there. This would break all this. This thing would just explode. It's orange. Sounds like something Jack would say. Yeah, program. Yeah. It's orange. Guys, the guy's really, he's really orange. Orange rocks. Good. That's what I'm trying to say. I'm 99% sure that rapid oscillation is the honking sound the Raptor makes when it shuts down. Yeah, maybe. So technically Raptor vacuum is like a shuttle engine hybrid, right? Its expansion ratio is very similar to a shuttle engine's, yes. Yeah, I see that the edge of the nozzle is like, yeah, there's like Contra, there's a reason why that bracing is there, because this thing would just pop. It would explode. Here, hold on. Here's a good example of what happens when that happens inside of a nozzle. Watch. Take a look. So this was the Northrop Grumman's Omega rocket test. Omega has since been canceled, which sucks, but oh, yeah. Watch that one more time. So there's a reason why that bracing is there, because if that bracing wasn't there, watch the nozzle. See it right there? Now keep in mind this is a solid rocket booster, not a liquid rocket booster like the Raptor vacuum is, but it's the same principle. Watch right there. Yeah, see that? That's not good for it. Yeah, I don't know if you knew that. See the part where it exploded? Yeah, that's yeah, see that? Yeah, see all those are pieces of the rocket's nozzle just flying all in different directions. That's what happens when you get flow separation in a nozzle. It's bad. Yeah, program, that's not ideal. That's not ideal. But once again, that's why SpaceX has that bracing on the Vector right there. See, look at that. That's some chunky freaking bracing. That's there on purpose to make sure it doesn't do that. So it's very interesting that they posted this footage, right? Because why? Why are you testing this? Shutdown of a Raptor vacuum engine in slow motion. The engine's nozzle is sized for use by Starship in the Earth's upper atmosphere and outer space, so operation at sea level and low chamber pressure results in flow separation, creating visible rings in the exhaust. I wonder if they just put that on there for just testing the Vectors down here, or if there's a specific reason for this. I'm pretty sure it's the former, but it could be the latter as well. Another stick rocket gone too soon. Yep. They have a massive flame deflector at Massey's Boca Chica being built. Do you think they will need a crane? Always. There's always room for cranes. So this only happens because it's at sea level. That's right, Kevin. Yeah, you got it, man. Mm-hmm. The weight of the entire atmosphere. Dude, think about this for a second. If you take 1 square inch right, at sea level, how much load is being put on that? How much pressure is there? 14.7 psi. That's 14.7 pounds per square inch, or 101 kilopascals, or 1 bar, right? All that air, right? All that air above this thing is trying to find its way in there. It's trying to find its way in there because the plume is collapsing, because they're throttling the rocket engine down. So the atmospheric gases, the pressure is trying to push inward. It's trying to push in here as the gases, as the explosion. The plain English way of saying it is that the explosion that Raptor is producing is not enough to fill the nozzle, so that the atmosphere, the ambient atmospheric gases try to go in. They try to go backwards through the nozzle, and that's why it creates such a turbulent effect here. Boom, 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 boom. Because right now, physics is like, should the gases be going in or should they be going out? I don't know. Like, which way do we go? Which way did he go, George? Which way? That's what's going on here. We get it. We get it, Vactor. You vape, right? We get it. You can blow rings. That's cool. Go post about it on Insta. Oh, wait, they did. Okay. Anyway. Could be testing to use all the engines during abort. Oculix, my guess is that they just put this bracing on there for testing purposes, just in case. But it's still cool to see. Hey, Wolf, what's going on, buddy? This is some really nice imaging. You can see that they have the contrast on this camera turned up to be able to image that the oblique shock collapsing, which is so cool. That's, dude, look at it collapse, man. There's not that much of a change in throttle, and the shock disc completely obliterates itself. What I'm trying to tell you is gases go in, gases go out. You can't explain that. You can't explain that. I mean, they can. They did. They've done that. Tide goes in, tide goes out. Would also stop the nozzle from deforming under its own weight, since they're not exactly designed to sit horizontal. Yeah, happy, yeah for real. It just works. So this means vacuum Raptors can't work at sea level, or at least can't be shut down and be relit? Oh, they can work at sea level, Lazarus. That's at sea level right there. It's just, I'm pretty sure they won't work very well without the bracing here. You're going to run into some extreme turbulence extreme transients on the rocket engine during shutdown. But Vactors shouldn't be lit. The Vactors shouldn't be lit anywhere near sea level in an idealized like Starship flight regime. In an ideal thing, it's going to do that, you know, and that's just the sea level engines, right? Yeah, Biff, that's exactly what's going on. Yeah, if you want to learn more about that, specifically when it comes to propulsion, which is what I like, propulsion is cool. That's called plume overexpansion. Plume overexpansion causes flow separation. Flow separation in the nozzle happens from cavitation. The plain English way of saying that is that the engine is not making a big enough explosion to actually fill up the entire nozzle. Ideally, you want to fill that whole nozzle and then some. And that right there is called underexpansion. Meaning that your explosion fills the nozzle completely and then some. Your nozzle is underexpanded comparatively to the explosion that the power pack and the combustion chamber is making. You want slight underexpansion for a rocket engine to be working well at sea level. You don't want overexpansion. You don't want overexpansion ever. But getting overexpansion in the vacuum is like, you would actually have to try to do something like that. Yeah. SSME was pretty violent at startup as well. Yes, precisely. Underexpansion is filling up the entire nozzle. Overexpansion is not filling up the entire nozzle. It's not backwards. Their naming is counterintuitive, Aqualex. The Artemis 2 Orion is heading into the chamber there, into the vacuum chamber. Cool. But yeah, that's an awesome video from SpaceX here. Very, very cool. Oh, yeah. Yeah, I don't hate that. Does that mean you can throttle down more in the vacuum? Yeah, sure. You ideally, it's not just about atmospheric pressure or ambient pressure, Finn, versus the pressure inside of the combustion chamber and throat. It's not just about that. Flow separation, I mean, for the most part, dude, yeah, like that's the reason why the RL10 is as good as it is, right? You could throttle down up there if you really want to. Getting overexpansion in the vacuum is like nigh impossible. Because there's no pressure pushing in. Your gases coming out are going to expand infinitely, right? That's generally the reason why upper stage engines have a much bigger nozzle. Because down here, you can kind of use the atmosphere to shoot that exhaust off in one direction, right? The plumes coming out of a first stage engine are more cylindric, right? And the plumes coming out of a second stage engine are more conical, right? And as the pressure drops more, the cone coming out of there gets even bigger, right? So yeah, you're really not going to get overexpansion up in space. That's not going to, I mean, but that still doesn't mean you want that either. Because at that point you have to worry about non-uniform heating. And also you have to worry about the structure of the engine. You know, upper stage engines tend to have that a gigantic nozzle. Like the Merlin vacuum engine's nozzle, I could stand up inside of one of those. It's gigantic. Merlin vacuum engines are almost 2 stories tall. Well, actually, let's say 1 story tall. They're pretty big for a rocket engine, right? But you have to really make sure you're still doing as much as you can to fill that whole nozzle up, because non-uniform heating in the vacuum can be extremely bad. You can melt part of the rocket engine. So in an ideal world, it's a good question. In an ideal world, could you throttle infinitely up there? Sure. Yeah. Yeah. But also you have a vacuum optimized nozzle, and you still have to make sure that explosion fits in there, or else physically the nozzle could explode. It's not just necessarily about ambient pressure. It's also about keeping the heating uniform on the nozzle. Did you see the new Lego Perseverance set they just released amongst the other sets? Yeah, program, I've seen it. It's pretty cool. Ship is going back to the Mega Bay, and the braces are taken off after testing on Pad B. Oh. Yeah, in theory, you could also have an infinitely long nozzle, but there are other problems doing that. Yeah, like, I mean, you could have an upper stage engine with a nozzle that's the size of a Saturn V if you really wanted to. Not sure how you're getting that into space, but it'd work. Mm-hmm. Yeah, pretty cool. Anyway, James, thank you for the Starship updates. I do have NSF Live going. I have NSF Live up here. I just heard about the Japan NASA pressurized moon rover. Yeah, Xenotechnic. Toyoda-sama. I'm retweeting that, retweeting the Vector stuff. We're going to say insanely cool flow phenomenon happening here. Yeah, yeah. Chat, proofread it for me. Proofread it. You're my publicist right now. Proof. Are we good? We good? Swear to God, if you didn't spell check this and I post it, I'm going to be a little upset. Who you got tomorrow, Denver or BU? Go for posting. Are those Black Sharks? These are Black Shark V2s, Happy. Yep. They're really good. We good, program? We good? We good? Appreciate all the knowledge you dropped for us. My pleasure. Okay. We are go for X post start. T minus 10, 9, 8, 7, 6, 5, 4. Go for main engine start. 2, 1. Post ignition. And liftoff. A semicolon? Ooh, semicolon. Wow, yeah, I think like you. Classy. Good for you. Oh, man, Scott already posted it. I was trying to give my explanation. Scott already posted it. He posted it 20 minutes ago. He has more likes than me, dang it. I'm kidding. Can you imagine? Can you imagine people are like that? It's ridiculous, man. Phenomenon. Do cock up poo poo. Would chat really let you post a typo? If I said proofread it, MoGame Pro, then they probably would. But if I didn't say proofread it, then they probably wouldn't. It's like dealing with a child. The child. Get ratioed, nerd. I don't mind being ratioed by Scott. That would be a point of honor. Also, I just want to point out here this thread that I started this morning. I'm trying to get better at crap posting on X. So I said SLS is Delta 5. No, I will not be taking questions. And Scott also, H3 is a relative of Delta. Yeah, man. Yeah. W plus good ratio plus I did ask plus I'm also interested plus wish you well. Rockets in bio. And Adrian said, can I argue instead of questioning it? No. I said, I'm not taking questions, Alex. Okay, so ignoring funding of any kind, what's the biggest hurdle for spaceflight right now? Gravity. No, are you talking about like from a physical thing? So this is my opinion very much, dude. Wildlife and fishing. The Department of Fish and Wildlife.
Discovery, go at throttle up.
Ooh, poison gifted a sub survey slave. Oh, God, it's so spicy. Oh. That's pretty funny, man. Ben, that was
Discovery,
good.
go at
That was
throttle up.
good. And you got gifted a sub too. Technical hurdle. Okay, so keep in mind this. Damn it, that was funny, man. Okay, all right. Keep in mind the biggest this is my opinion. So I think the biggest hurdle is fairing size, payload bay. Dude, we're not gonna get to the point where we're like at Star Trek levels of craziness without being able to move higher masses into space. I swear I'm not just parroting Elon, because this is pretty much exactly what he said in the Starship Hands-On that we watched yesterday for Space News, right? I think that payload bay size is the big one. Because look at SLS. SLS is great. SLS could arguably do like 150 tons into LEO if you had a proper third stage on top of it, right? I think it could. I really do. I think you give it the EUS and you give, You could put lead in the universal stage adapter on block 1B and it'd probably get it up there. Now, with that being said, the universal stage adapter is only 8.4 meters wide. And even Starship's payload bay was probably about the same size because Starship's a 9-meter core. The payload bay is not going to be exactly 9 meters. You have like stuff like the header tank plumbing lines on Starship. So Starship's payload bay is probably going to end up being like an 8-meter payload bay, right? Even an 8-meter payload bay, like we kind of did some kind of analysis on this a little while back. Starship has about 1,000 cubic meters of payload bay volume per Elon, right? Like, and we did some math out behind it to kind of, it's like 980 something cubic meters. It's a big payload bay, right? Dude, and so Starship, Elon said that Starship could theoretically in the future move like 200 tons into space. Dude, you could fill that payload bay up almost completely with lead, and it would still get it into space. Now, are most payloads made out of lead? No. The point that I'm trying to get at is that you're on Starship, even Starship at this point, right? Even with that 980 something cubic meters of payload bay volume, an 8-meter diameter payload bay, right? Volume is the constraint here, not mass. Think about it. Volume is the constraint. We need bigger fairings, dude. On SLS, I don't know about Starship. Starship might be able to overcome that if it launches every day. That was their solution with the Space Shuttle. Space Shuttle's payload bay is no bigger than any other rocket. It's actually about the size of a Titan 4 fairing. Or Titan 3 fairing, I should say. Gee, I wonder why. But because NASA foresaw this thing launching every week, having a regular sized rocket payload bay launching every week, well, that's a completely different story. You could build modular space stations in a couple of months. So I think we need I think we need bigger payload fairings. So where am I going with this? Sorry. Where am I going with this? I kind of trailed off for a second there. Starship is fine with its 8-meter, 900 cubic meter payload bay volume. That's okay. That's fine. And that should be able to move a good majority of payloads into space. But having something like a 10-meter fairing with SLS, heck, even an SLS core stage with just a fairing on top and no upper stage, that would really move us to the point where we could build ridiculous things up in space. Now, once again, Starship with a higher, even Starship with like a weekly launch cadence, let alone daily, a weekly launch cadence with an 8-meter payload bay volume should be able to mean that like we could, launch pretty crazy stuff and then assemble it shuttle style. I actually hope that Starship does that eventually. Like nothing would make me happier seeing a Starship fly around up in space with shuttle style payload bay doors and a robotic arm building a space station. So size does matter. Oh. In the universe, absolutely. If you want to go further, you're going to need a bigger rocket. Physics doesn't lie. So what you're saying is stretch Starship even more. Yep. Thank you for your answer. It was almost coherent. Jokes aside, you made a great point. Yeah, I think payload bay volume is the big constraint right now. It's very clear that SpaceX can yeet a 100-ton spacecraft into space pretty much willy-nilly at this point. But like I said, even if you filled that thing completely up with lead, it would still get it into space. So, but why would you fill it up with lead? Well, wouldn't. Even the most densest of payloads, Starship will be able to get it into space. Payload mass is not the constraint here. Volume is. I think that's the biggest technical hurdle. Volume, yeah. So you could either, once again, and the two ways to either go at that problem is full reusability with high launch cadence, Starship, or lower cadence with a much bigger fairing. And that's why I think SLS with like a 10-meter fairing would be amazing. What will be the next big jump in rocket engines? Rotating detonators all day. RDEs. Starship V4 will be the answer. Program, why don't they just rip the Band-Aid off, dude, and go back to ITS, please? Please do not make... Dude, please don't make that long Starship. I beg you. Just don't make that. Just please don't make that. Please don't. Just increase the core diameter, please. Please. Or do something like Centaur G here. Like Centaur G Prime, just use something like that where you're using a similar thrust structure with a widened mid. Please. That long Starship looks silly. Please just do something like that. Just widen the core stage. Please. You don't like the long boy? No. It looks like Long Cat. Just do the ITS thing that you originally wanted to do, please. I bet you Starship V3 stretched more to increase payload volume rather than tank volume. You're probably right, Aqualex, but you know the irony in that statement is that they probably increased it. They probably increased the payload bay volume so they could move more fuel up into space. Right? But yeah, no, I get what you're saying. No, you don't want Long Starship to be bulgy for reasons. I do, though. I'd rather this than Long Starship, okay? I remember when we watched a technical video on stream of an RDE years ago, and that video itself was old. It could only run for a fraction of a second. Now they're up to minutes. Crazy stuff. Dude, if RDEs take hold, Happy, yeah, a Hydrolox RDE is... Look, all I'm saying is that makes SSTOs a little more viable. Just saying. No, all system. No, not that. Explain what a rotating detonator is. Worst. Rotating strap-on detonating. Guys. God damn it. All right. So what's a rotating detonation engine? A rotating detonation engine is a rocket engine utilizing what's called an annular thrust chamber with a spiked annular nozzle. Okay, so what does that mean? It means it looks like a jet engine. All right, now why? Why does it do that? What's the point? How's it a rocket engine if it looks like a jet engine? Well, what it basically does, a rotating detonator engine, is basically it kind of has detonation waves going around this annular thrust chamber in a helix, and there's 3 of them that are kind of equally spaced apart. So they're kind of shooting out a detonation wave out the back. So if you think about like the V1 rocket from World War II, that's a buzz bomb. All right, so it makes that noise. The mic doesn't pick it up. There you go. Pick that one up. So yeah, it's a pulse jet. Basically, there's a valve that's moving back and forth and creating pulse detonations out a nozzle. So those pulse detonations, depending on the frequency of the detonation, makes it sound like like buzzing, like bah, right? So what a rotating detonator does is instead of sending detonation waves linearly down a pipe, right? The rotating detonator engine has 3 pressure waves constantly circling in kind of a helical motion around an annular thrust chamber. So what does that mean? Okay, all right, why is that a thing? Who cares? I mean, great, helixes and stuff, Gattaca, right? Okay, that's a thing because the problem with the pulse jet is that you're not always making thrust. It's thrust. Once again, depending on the frequency of pulses, right? So there's points where between detonation waves where you're not making any thrust. That's why it makes the buzzing noise, right? The buzzing noise. So a rotating detonator engine gets around that by rotating the detonation waves instead of sending them linearly out the back. This makes an engine that is producing a constant detonation out the back. Now, okay, why is that a big deal? So, in order to understand that, you have to understand the difference between deflagration and detonation. What's the difference here? Deflagration is some type of explosion that happens where the pressure wave is subsonic and not breaking the speed of sound. Everything that makes power in our civilization, internal combustion engines, diesel engines, jet engines, all combustion. Rocket engines, all combustion. That's all combustion. It's happening at a subsonic. The combustion and the resulting explosion and the waves from basically the gas is moving from the explosion are traveling at subsonic speeds, so below 700 miles an hour. In a rocket engine, I know what people are going to say. What do you mean? So how does a rocket engine get past the speed of sound? Like, how does that all work? Well, a rocket engine has the throat, and in the throat, the gases are accelerated. That's the difference. That's why a rocket engine is not just a straight pipe out the back, right? It looks like an hourglass. That's the reason. Now, so, I mean, there's tricks to accelerating them, but even the gases coming out at the nozzle, coming out at the end of the nozzle, like what we saw in that Raptor video a second ago, those are still going subsonic. Now, that's deflagration. That's combustion. So detonation is over here. What's that? Detonation, as you may have guessed, is an explosion where your pressure wave is traveling faster than the speed of sound. Okay? Now, rocket engines, in essence, a rocket engine or any type of aeronautical, aerospace propulsion systems, jet engine, rocket engine, whatever, they're all dependent on equal and opposite reactions, right? It's basic physics, right? So like the most primitive form of a rocket engine that you could actually have is like if you take a balloon, you fill up a balloon and you let it go and it does the farty noise. You know? That is a rocket engine. All you're doing is accelerating gas through a confined space. That's it. Right? So, how fast that gas goes out of the rocket engine is a really big determining factor for a rocket engine's efficiency. From your exhaust velocity, you can derive total impulse, and from there you can derive specific impulse. Also, if you're accelerating the gases out the engine, at the back of the engine faster, you're making more thrust. Yeah. More gas going out faster, more thrust, more efficiency. That's where rotating detonation engines can change the game. We're talking about specific impulses that are way higher than any rocket engine we have working right now. Well, that's flight certified. Detonation engines can shoot gases out way faster than a regular rocket engine. And if you combine that with the efficiency of like hydrolox or even methane, for instance, right? Which NASA is testing right now. They're testing with methane. You can combine that. Well, you can make a rocket engine that is insanely efficient and also insanely powerful. Yeah. Really, really cool. So you could theoretically make a rocket like an SSTO would be back on the menu, right? Because you don't need as much fuel. You get much better impulse out of the same propellants that would be way worse. Think about it like this. If I have a Volkswagen Beetle, right? And I fill that thing up with 5 gallons of gasoline, okay? And then I have a pickup truck next to it, and I fill that up with 5 gallons of gasoline, right? I know they're both using internal combustion engines. I get it. The engine isn't part of the analogy. What can go further with that same amount of propellant? Well, it's a Beetle, right? It's less mass. Engine doesn't use as much fuel. Simple as that. It's basic physics, right? Now, once again, I know a Volkswagen Beetle and a pickup truck have the same. They're using the same engine. They're combusting, right? So probably wasn't the best analogy, but actually a better comparison would have been a diesel to a gasoline engine, right? They're both kind of doing the same thing, but they're kind of not. The idea here is that you can go the same. You can accelerate to the same velocities with a lot less fuel. And you can go accelerating to a velocity is the name of the game with rocket science. That's the most important part. How fast you can go. It's not how far you can go. If you said to a rocket scientist, I have a rocket that can go 250,000 miles to the moon, they'd be like, all right, cool. If you said to a rocket scientist, I have a rocket that can accelerate to 25,000 miles an hour, they'd be like, oh, you can get to the moon. That's cool. It's measured in change in velocity. So your acceleration, it's not how far you can go, it's how fast you can go. Detonation engines, because they shoot gases out way faster, because they can shoot gases out past the speed of sound, you can be way more efficient, and you can make way more thrust. It's really freaking cool. Will this be on the quiz? You're damn right it will. Yeah, there you go, worst. All right. Elon Muskrat had a 22-month resub after that. A little before that explanation. I really do appreciate it, man. Thank you very much. Okay. That was 4.5 hours of space news. Pretty good. Space news is coming back. 5 o'clock every day. Be there, be square. Except on Fridays, because NASA Spaceflight Live would be at 7. So, yeah. We're doing it. I'm getting back into it, guys. We gotta get back to rockets. I love my workers and resources, but we need to get back to rockets, and you know what that means in the future. Yes. Yes. Imagine a rentable Super Heavy with bring your own rocket program. Yeah, right. Technically, NSF Live is space news. I'll take useless comments for 500, Alex. We need more. Not enough. All right. Joke's on you. I'm already here and a square. I mean, program, you were doing dishes and you didn't write any of that down. Well, you're failing that exam. Detonation, make gas go faster. Go further in space. That's all you got to know. All right. All right. Shall we, workers? Shall we? Shall we? Let's shall. More KSB. It's coming in the future. KSB 1. KSB 1. KSB 2 still needs more time in the oven. It's a souffle. It's going to take some time, okay? For 30 minutes, question? 30 minutes. Oh, crap. That's right. We have a stop time at 9 because Brimo wants to watch Fallout. Better be good, Todd. Better be freaking good, Todd. This better be good, man. You're keeping me away from my workers and resources. Planning on playing Call to Arms again in the future? Yeah, sure. LM, maybe we'll play it after hours tomorrow. After Space News tomorrow? Sure. What is Fallout showing on? This TV service. Gamecast. Appreciate the cliff notes. I got you, man. Perfect. That game was really fun to watch. I did enjoy it, LM. Yeah, I like Call to Arms a lot. It scratches, to put it in Etel's words, it scratches the combat tactics, cover and concealment, itch that I didn't realize okay, let's be real. I'm a Counter-Strike player at heart. I needed something like this. Yeah, it's good. It's good. Y'all got any more of those Call to Arms? Y'all got any more of that? Which service has Fallout? Prime Energy Drinks. Let's hope it will be good. You never know nowadays. I hope it just works. I really do. They released it a day early, so yeah. I guess I'm gonna go do that because 20 minutes isn't enough to play Workers and Resources. So once again, we'll call it at 8. We'll call it at 8.5 hours here. That's a short stream. It's a little bitch boy stream, dude. And we'll do a long one tomorrow. We'll do Workers, Space News, and Call to Arms. Okie dokie? Let's see who we can raid. Dogs. Sup, dirty dogs? I wasn't going to say nothing, but yeah. We haven't re-rated in a little while. Yo, what's Hurt up to? Yo, Hurt's streaming. Let's go see what Hurt's doing. Oh, he's just chilling watching car stuff. I'm going to go watch car stuff for the next 20 minutes with Hurt. Hurt's my buddy, dude. I bought the 97 from him at his previous place of employment. It's a good time. Let's go raid Hurt and see what he's up to. If you like cars, yeah, Hurt's you're probably going to want to watch that. Poison's last. Go surprise Brimo with some popcorn or such with your newfound free time. Bro, I already had the popcorn. I already had the popcorn in the cabinet, man. You always have popcorn ready for your lady. What's wrong with you? All right, so when we raid Hurt, we need to do okay. This raid message is not classy, but please type it. You need to do that. Type that with some panels. Go. Make it happen. 2JZ, no snot raid. There you go. What Shaw did. Do it. Go raid Hurt. I'll talk to you guys tomorrow, noon times. Thank you very much for watching. Have a good night.